documents, how do we make sure that our large language models are providing the correct answer? So that is kind of like the basics around this research. The second one is a RAG or retrieval augmented generation based systems complemented with the LLM system. And that is kind of like addressing the challenge that I just discussed in the previous slide. How do we do a natural language based query in the PDS system and identify some images? And the third project is actually kind of like ongoing. These are kind of like, those two are completed projects. We already have the publication based on that. The third project is still evolving, but the idea is that can we actually use the zero shot or few shot classification based on the LLM systems, and then also not just single level classification like, is this a picture of a crater or is this a picture of a dune or something like that? Can we do a multi-level classification? For example, some kind of like crater, then whether it is a fresh crater or some old crater, is it a large crater, small crater, something like that. So can we use the MLLM, multimodal LLM system, and use the zero shot and few shot classification algorithm to do that kind of like hierarchical classification? That's kind of like the research question for the third project. So project number 1, the research question that I was exploring was that how can LLMs accurately trace information to specific pages in technical document? And this project, again, the use case came from our NASA JPL collaborator who actually has to go through a lot of very complex technical document. One of the particular document that they were dealing with the daily basis is called MOTREN. That's kind of like a document that tells them how to model the atmospheric behavior in the earth, and it is a very complex document. So instead of looking throughout the pages and everything of the document, they want some kind of like LLM based facilities that is going to help them to do some natural language query on that document and get some information that is verified, like which page it is coming from, which section it is coming from. So that is kind of like the use case that we dealt with. So the challenge basically is that whenever we are using some simple LLM like Gemini to ask some question based on that MOTREN technical user manual or documentation, as you can see, Gemini gives a very verbose answer, like a lot of answer, and it hallucinates. So lots of those answers are not correct, but it is giving a very confident results, whereas the real answer is this. So the first research gap is the standalone LLMs lack domain knowledge and verifiability. Sometimes they hallucinate incorrect details. Then the second research gap is that if we use some RAG-based systems, where we are providing the additional context, let's say that we are providing the PDF of that MOTREN document as the context for the RAG-based system, then little bit better results. As you can see, it will be able to tell me like how to answer the question of this one. However, if I ask that, like, for the source verifiability reason, like which page you are getting this from, then it cannot give me that, because RAG actually do not provide that kind of like page level metadata along with the data that is taking. So the proposed solution is that PageLog QE, that's the system that we name for. That is a lightweight open source RAG framework for page level attribution with verifiable sources. So let's see how the PageLog QE is actually framework is actually working. So basically the documents are chunked into 500 character segments with 100 character overlap. So each chunk gets tagged with its page number. That is the key over here. So whenever we are chunking the document, we also keep the page number along with the chunk. And whenever you ask a question, okay, based on a natural language question, the system then searches those through chunks to find the relevant pages and the necessary information. It also uses some manual tool routing, and which I'm going to explain in the next slide, and do some intelligence like reasoning or routing of those search questions. And then it presents not only the answer of your question, but also the page number where you can find that particular answer in that, the document that you are searching for. So the key innovation is we just don't point to the documents, but we also point to the pages. And this makes verification fast and reliable. And you can chat with those technical documents and get precise page citations. So a little bit more about the manual tool routing that I mentioned. So there are two components of the tool routing. So basically, if you are doing a what kind of like questions, like what is this or what is that, then it actually basically use the basics tool routing and perform a keyword search based on FICE. So whenever it happens, the top 13 of that results actually get extracted along with the page metadata, and then those are presented to the LLM to find the answer and the citation. That means which page it is coming from. However, if the question is like how, why, those kind of like question, then we have an additional routing reasoning tool that performs some semantic search and re-ranks like those 13 and to get only the top 5 chunks, because for how and why questions we found out that method to be much more effective, and then those higher quality top 5 chunks are then presented to the LLM to explicitly find the answer. So the magic is not just the retrieval, because there are a couple of things we are using in this system. Of course, the LLM, then the RAG, which is the retrieval generation framework, and also some structured prompting, and then this reasoning and routing tool. That's all actually happens, and then that's behind the magic, which actually gives us the page data as the answer as well. So I have the GitHub link at the end of my presentation where you will be able to download this Streamlit GUI, where you can download and then upload any PDF and then do some natural language query based on that. So just a screenshot of this document. I'm not going to be doing a demo because of the time, but you can download it and then you can ask those questions based on any PDF documentation, technical documentation that you are uploading, and then it should be able to give you an answer along with the which pages it is coming from as well. So let's see some quantitative results of our system based on some, the AI evaluation metric, which is the BART score. So if you are not familiar with the BART score, it is basically a scoring mechanism that's kind of like compare the machine generated text and the human generated actual ground truth, and kind of like understand the context. So it doesn't has to be like word by word exact match, but it understands the context and then generate some like percentage of matching. For example, over here, if we are seeing the number 846, that means that the machine generated predicted text is actually 84% or 85% matched against the actual text. So in this experiment, we experimented with our PageLog QA, but we also used 2 more models, which are very particular models for those kind of like question and answer. We call them Q&A model. One is called self-reg, another one is called ChatQ. And of course, we evaluate that along with our Motren model, where we want the answer and page number. We also did a separate study where we only did the Motren manual or technical documents, but we only ask the question based on the page, like which page it is coming from. But along with those two, we also get some popular, the general purpose question answer like FAQ kind of like database. One is called Hotpot QA and another one is called Trivia QA. So we also execute our system on those things along with comparing them with those models as well. So as you can see, the BART score telling us that the PageLog QA is performing comparably along with the other 2 model on those kind of like traditional FAQ systems or databases. But whenever we particularly do the technical, as I mentioned, very complex technical documentation, the PageLog QA outperforms those models by a significant margins. And particularly whenever we only ask about the source level questions, like what is the page number or where are you getting that information from, then you can see that it outperforms those models by a very significant margin. We also did some evaluation case studies. So we did like normal LLM without anything, and as you can see, the accuracy is 80%. And then we added the RAG, so LLM plus RAG. The accuracy we achieved is 85%, but whenever we did all those other things like prompts, then manual tool routing, then page level chunking, and everything that we implemented in our PageLog QA, we received the 87% of the accuracy. If we are thinking about the time wise, you can see that only LLM takes significant amount of time to get the answer, whereas the PageLog QA, once you are done uploading the document that you really want to query about, it actually retrieves those answers very, very quickly. So the main finding is that the full PageLog QA pipeline with routing and prompting is not only the most accurate, but also the fastest, providing the smart and lightweight logic. It is more efficient. Lastly, we did some qualitative study. So we asked some question. For example, the first question is that how to call Motran GUI. That is one of the typical question that it belongs to that document. And as you can see that PageLog QA answered correctly along with the page number, whereas Chat QA kind of like hallucinates. Self-Rec QA also gave some hallucinating answer. This is incorrect, this is hallucinating answer. And over here for another question, it also, the other two model gave some vague answer, whereas the PageLog QA correctly able to generate the correct answer along with the page level attribution as well. So the main finding is that the lightweight beats the complex for specialized tasks. So again, this is for a special purpose system, only for technical kind of like documents, natural query based on the technical documents. So manual routing outperforms agentic systems or technical documents. Page level grounding is achievable without fine tuning. So we did not have a costly fine tuning of an LLM system. Basically, the techniques we used here are the RAG, manual routing, prompt engineering, and also the page level chunks. So those are the techniques that we use, but it runs locally. So whenever you will be able to download the system, you will see that there is no cloud dependency, there is no costly API calls. It will learn locally, and then it will be able to answer your questions based on your natural query-based system. So that is the first project that I was planning to present. The second project is basically centered around the research question. How can MLLM and RAG enable natural language access to NASA's PDS system for non-expert users? So the challenge, we already discussed it in the very first slide. So again, the question is that PDS hosts lots and lots of pictures, images of many planetary systems, but how can we, non-expert like us, can search those archives effectively and get some pictures? So for example, if I do a natural query search, like find images of land patterns caused by sublimating carbon dioxide, how can I get some meaningful images back? So that is the question. And of course, who is going to be affected about this research? Student, educators, interdisciplinary researchers who lack specialized planetary science expertise, but we want to do some more research on those images. So here is the framework for that system, and the technique over there, we use basically the LLM and the RAG framework. So as you can see, first the metadata of the image. So all the images in the PDS system has some metadata. So we feed them, and then we use the BM25 algorithm for precision ranking those documents or metadata. Similarly, whenever user also did a query, we use the same process to rank, and then the text embedding is used, and then those embeddings are stored into a vector database for search. And then when the query is presented and matched against those metadata, then if there are more than one matches, then we do have a disambiguation module working over there that actually use a threshold of 0.80. So if there are like more than 2 or 3 things are matched against the user query, then use that threshold values to determine which one is the most relevant one. And then once we figure out what the user is actually looking for, the system generates the URL that is a clickable URL. So you can click to that URL and it will take you to directly to the PDS site showing the image that you are looking for. So all the natural language query that we are seeing in the previous slide, like find the images of sublimating carbon dioxide or something like that, it is going to ultimately give me a URL, clickable URL, and a corresponding images. So the research team also designed a Tinker GUI, which is going to allow us to do those real-time querying of the system. And again, this is also a standalone system, so we do not need to have some fine-tuned system or specialized hardware to run this one. And here again, the the screenshot of the GUI that takes that query as an example, as an input, and that ultimately generates two of those images. One is called belong to the spider, because the sublimating carbon dioxide can generate some spider group of terrain, or maybe the Swiss cheese group of terrain. So both of them came, and then those are the clickable links, and then we'll be able to directly go to the images based on our query. So that is kind of like, again, allowing access to these image data sets, which otherwise will not be accessible to the non-expert users like us. So we did some testing based on the framework. So this is the direct approach, basically just asking the large language model, nothing special, but this is our framework. So as you can see, we actually tested our system with 100 of such queries that you can see over here. And it actually accurately can point to the correct image in all of those times. So accuracy is kind of like perfect for our system. Excuse me. Whereas for the LLM-based system, it is much lower. However, if we are talking about the processing time, there is a caveat over here. As you can see, that it takes much longer, actually 69 times longer in our RAG approach compared to the direct approach. However, this is, I think, again, this is like we are still talking about the seconds. It's not like minutes or days or something like that. So I believe that still it is acceptable, because what we are gaining, on the other hand, is the ability to search those data sets based on some natural language query. For example, I can ask like, find some images of crater. If I am very naive user, I do not know those technical terms, I can say, hey, show me some images of, streaks or some flowing structure in Mars, or some ice patterns in Mars, or some rocks in Mars, or something like that. So yeah, it actually allows us to use those scientific, natural language query in the system, although with some little bit of time, additional time. So the project number 3, that actually is, as I say, the still evolving project. It is not matured yet, so we did not actually published yet, although a paper is waiting for review. But the question, we are kind of like tackling a much larger or bigger level of question, which is that can we do some hierarchical prompt-based LLM and use the zero and few shot classification of those images. So what we are trying to achieve over here is that basically looking at an image and whether the MLLM system can classify it. And not only just a single level classification. For example, this image should be a single level classification like impact crater, because there is a crater has been created because of an impact in the Mars surface. Maybe some meteorite or something, some object actually hits the surface, so there is an impact generated and the crater is created. But we are not only interested on the label 1, we also want to know whether there are some further classification can be achieved. For example, is it a fresh crater? Like, is it a recent crater? So this crater is from 2010 to 2012. So we would, in planetary system time, it is relevantly fresh crater. Maybe we are also want to know whether it is a big crater or a medium crater or a small crater. So those kind of like understanding, can the MLLM help us with those kind of thing? Or additional characteristics, as we can see, like, blast rate zone, dense secondary crater field. So you can see some other crater alongside this one as well. Ray distribution. So crater actually created some ray kind of like distribution. So these are additional characteristics. So the question is that, can we use the large language modeling system who is going to take a image as an input and can give us some kind of like hierarchical classification based on that image? So that is much, as I say, much larger or broader research question that we are investigating. So before I show you the hierarchical classification, I want to make sure that we understand this group of images that this research is exploring. So we are looking at a particular subgroup of Mars images captured by a instrument called HiRISE. And the researchers actually came up with 8 categories of those Mars images. One is called bright dune. So you can see that it's kind of like dune, kind of like structure, but they are sometimes looking like bright ones. On the other hand, you have dark dune. So this is again dune, kind of like structure, but these are much darker. Of course, this is crater, which is created because of some impact on the Mars surface. Then impact ejecta, we just saw this picture in the last slide, which kind of like ray kind of like coming because something hits the Mars surface. Then the other is all the other pictures that scientists cannot actually fit into according to a particular significance. Then the slope streak is another particular kind of picture where you can see some kind of like flowing pattern you can see in the Mars surface, and that is usually created by dust. So dust kind of like flow because of the high wind, and it creates some flowing kind of like structure like that. So the scientists call it as slope streak structure. Then the spider, so as you can see, the spider kind of like pattern actually created whenever there is a kind of like what can I say, like geyser kind of like structure came out when in the cold season, the carbon dioxide, which is basically the main component of Mars, actually got frozen, and then in the springtime those gas underneath kind of like came out as a geyser and created those particular pattern called spider. And then Swiss cheese is also another one that is also terrain type that consists of pits that are formed when the sun hits the ice, making it sublimate. So this is again another kind of like distinctive patterns that happens in the Mars surface. So these are different geological features that can happen in Mars, and the hierarchical classification algorithm that we devised actually are only taking into account those 8 different kind of like structure because scientists actually identified them. However, in general, the challenge is that whenever we are thinking about, okay, we have some images and we know that there are many very effective deep learning methods like CNN are already available there, which can classify images very accurately. But we need to understand that to be able to do that, we need label training data, which may not be available if we are talking about a brand new mission. For example, some mission that NASA is executing and they are sending all those pictures, the expert didn't have any time to sit down and identify the images and classify the images like this, like the bright dune crater, so that we can actually feed those label images to our traditional CNN or machine learning algorithms and then can get some answers. So this is not applicable. The CNN based approaches are not applicable if we are talking about like brand new mission data. And then of course, all it can generate, even if we are thinking about the traditional machine learning algorithm, is a single level classification like bright dune, crater, dark dune, or something like that. So the question is that can we go more deeper? Like can we generate the classification, number one, without any label data or very few label data? And second question is that can we do some hierarchical classification or much more deeper understanding of those images? So let's see our approach. Very basically, we use the zero-shot hierarchical classification MLLM prompts. So basically, zero-shot basically means that we are not giving the MLLM any context or anything. We are just basically presenting the image, and then by doing some clever prompt engineering, we are asking the MLLM to give some level 1 classification, level 2 classification, level 3 classification. So our prompt is basically like this. So in label 1, we are asking, is the image belongs to a crater? Is it a dune? Is it a volcano? Is it some slope streak or some flowing kind of like structure? In the second level, we are asking much more specific characteristics. So if it is a crater, is it a fresh? Is it a degraded? Is it a simple? Is it a complex dune? For dunes, is it a linear dune? Is it a star dune? For channels or flow-like kind of like structure, we also are asking, just identify those things. And then in the level 3, we are asking, give me a confidence, like, how confident that you are actually about whatever you generated as your level 1 and level 2, and give me also some unusual and scientifically anomalous features if you identify anything, and also tells me whether you are very confident and this image does not need to go through the expert, or does it has to go through some expert for further evaluation. So this is the level 1, level 2, level 3 prompt that we use for our zero-shot hierarchical algorithm, classification algorithm. And let me give you an example what the MLLM is actually generating as an output for a single image. So when we present this particular image, which is the ID, and later I will give you the data set where this image is coming from. So level 1 has been generated as a crater correctly, but as the level 2, you can see that it identifies that the image has detailed some features, for example, circular shape, circular raised rim, spans about 25% of the image. It knows that sunlit inner wall, okay, then it also identifies some dark shadowed floor, then subtle wall slumping, modest ejecta. So a little bit of ejecta, as you can see, very fine lines, but as you still can see. So it identifies all those things as the level 2. And then it even says that no frost or dune material is present. And then as a level 3, it gives a confidence of 0.74. And as an anomaly, it identifies that fairly, it flags anomalies like the asymmetric terrace and recommends expert review because it is not very much confident about the generation of its description. So you can see that, all this is coming from a single image and some good prompts. So no training, no label data, just intelligent prompting of a vision language model. And this is the power of the modern multi-level AI. So this is very powerful. And as you can see that using this one, we can actually, it is possible to achieve some multi-granularity scientific details based on just an image without providing any context or anything else. So whenever we are actually using the zero-shot classification, so we actually compare our results with another study which has been performed by a group of NASA scientists, and it is published in 2021, and they did exactly what we are talking about. They did trained a fully trained CNN classifier that was trained on those 8 predefined classes that I showed you in the previous slide, like crater, bright dune, dark dune, slope stacked, all those classes. And the data set is actually coming from this Genedu data set. So this is the link where we get our data sets from. So we actually run our zero-shot classification algorithm exactly on the same data set that they did, and their results were 93% accuracy, but that required 6,000 label images. So they need to spend hours of expert times. Some experts actually go through those 6,000 images to label them so that those labeled images can be used to train their CNN classifier. And of course, the weeks of training as well also needed. On the other hand, our zero-shot classification algorithm, as you can see, overall accuracy, it achieves 71%. For some classes like crater, it actually achieves much better accuracy than even the CNN. But for other classes, it is not that confident. But the key thing is that there is no training required, no labeling of the images are required. All we need is some clever prompting and some good data set, and then a good use of the LLM. So for this zero-shot classification, we actually used the very recent GPT-5 model from OpenAI and was able to get some good accuracy based on that. So these results actually inspired us to go one level higher and do a few-shot classification algorithm. So in few-shot classification algorithm, we are not going to be naive like zero-shot. So in zero-shot, we did not provide any context to the LLM, but for few-shot, we actually ask our GPL scientist to give us some 50 per category images which are labeled, which they know that this image belongs to the crater, this image belongs to the dark dune, bright dune, all this kind of thing. And then we ask, ask for an unseen image. So we present an image to the system and we ask it to compute the clip similarity between the unseen image and all those example images. So CLIP is another vision language model, which are very good to generate the description based on the images very, very accurately and time concisely. So we use the CLIP to generate image description based on the unseen image and all those 50 category images that our GPL collaborator provided. And then we ask it to select 5 most similar examples images. And then we include 2 contrasting examples which does not belong to anything that the system identified as most similar. Then those 7 images are presented as a few shot or labeled prompt to the LLM system with the prompt something like, given this 7 reference example, now classify this unseen image. So this is like the results that we received after doing that few shot classification prompting and this particular methodology that I described over here. And as you can see, the accuracy is now much more better and it is almost comparable to the CNN accuracy that the researchers received on in their previous study. So for some cases, it actually 100% accurate, like bright dune or crater, it is very much accurate. On the other hand, some of them, the system is a little bit confusing. So again, the insight over here is that few-shot MLLM has the potential to classify images with comparable accuracy without needing any extensive labeling. So you have to think about like 50 labeling compared to 6,000 label that they used in the CNN classifier. So for any kind of like newer mission or newer images that NASA is generating based on their missions, all those can be very quickly can be classified or identified based on this few-shot classification algorithm, and that has the potential to do that. So that is the kind of like key insight from there. But we did not actually stop only the classification stage. As I mentioned, our interest is that can we also identify some subgroups or some hierarchical category of those labels? So for that question, we actually did a methodology which is grouped data by label column. So whatever the label is given by our few-shot or zero-shot classification algorithm, like label crater or dark dune or black dune, I also show that they also generate some label 2 description and then label 3 anomalies, all those things. So we did the TF-IDF vectorization of the label 2 descriptions that I show in some previous example, and then those vectorization and then went through a K-means clustering to identify some cluster based on those description. And then from those clusters, identified cluster, we use the topic modeling LDA algorithm to identify semantic themes out of that. And then we created PCA visualization, principal component analysis visualization, to show the cluster separation. And by using this methodology, we are able to identify 18 totally new subcategories which scientists did not identify before, the JPL scientists, based on those 8 main classes. So in the next slide, I'm going to show you some of those subcategories that our few-shot, zero-shot, the label 2 description, based on those description, we are able to identify. So not only just crater, it also identifies that crater images can belong to one of those 3 categories. One is the simple bowl kind of like shape craters. Then there are a large single crater, so only one single crater but very large. Some of those images belong to that category. Then there is another category called multiple small craters. So the beauty of this kind of like subcategorization is that now as a researcher, I do not have to ask the system like find some images of crater, but I can also ask like find some images of large single crater for my further research or something like that. And as you can see, there is a clear separation between those clusters. This is the PCA visualization according to the component, first and second component analysis. So as you can see, the clusters are really pretty good separation, and the system was able to, our methodology was able to identify that. Similarly, for the slopes track, it also generates some very intuitive and detailed classification, like is it a single wide streak, is it multiple narrow streaks, or is it frost related features. So again, the clusters are very unique and separated. And for the bright dune, it also able to identify whether the bright dune coming from the polar pits or the spider or the deforestation, or for the Swiss cheese is also able to identify the subcategories as well. So the unique thing about this kind of like subcategorization is that, of course, the scientists only knew about those or identified those 8 categories, but now we can actually generate more knowledge based on these kind of like algorithms and use of the LLM. So the subcategories are distinguished by, as you can see, size and scale, multiplicity, so is it a single or multiple feature, morphological type like bowl-shaped or complex crater or some kind of like other shapes, seasonal states like is it frost-covered, meaning like winter season, or defrosting patterns, or something else which is igniting some other warmer seasons, preservations do those kind of like subcategorization. And some kind of like some categories are having very clear boundaries, whereas some other ones actually has fuzzy. So actually there are a critical identification over here. So we after going through all those results, we identified that the spider, although it is a separate class, some of those spider images or characteristics actually also belong to the bright dunes picture, and some of those impact ejecta characteristics also belongs to the Swiss cheese feature as well. So maybe scientists needs to reclassify based on that additional knowledge and then go back and then reclassify all those images as well. So this is actually a lot of kind of like scientific discovery based on very simple use of prompts and zero-shot and classification few-shot algorithms that we just discussed. So in summary, today I discussed 3 research projects that me and my team are executing in our university. The first one, PageLog QA, basically allow us to do the source level verification. So it prevents hallucination, and then allow us to do some high-stake domain-specific question answering system. Then the second one is like accessible querying. So we are able to access a very large scientific repository, image repository in particular, and then we'll be able to ask some natural language question. And the third one is the intelligent classification. So we were able to receive some very good promising results based on our zero-shot and few-shot classification algorithm, and able to use some hierarchical classification instead of a single level classification. So the potential impact is to be able to scale to very large number of images. Instead of weeks of training, labeling, we need only few examples or labels, or some time, considerable time. It is verifiable, trustworthy results, not hallucinated results. And then also we are able to generate, as I say, as a scientific discovery, 18 new subcategories were identified. And the application is not only, although all the use cases and application I discussed over here within the NASA archives, but this could be generalized to, as I mentioned, any particular domain like medical imaging, satellite data, technical documentation, any scientific repository or documentation. So the references, so the first 2 projects are already published, and this is the GitHub repository where you will be able to download the system, the PageLog QE, and the whole projects are actually supported by NASA grants, and we are also thankful to our JPL collaborator for their insights and help throughout this research project as well. So if you have any question, I'll be happy to answer that. Okay, sure. Of course, I will look forward to that. And yes, I will try to answer my best to your request, to your questions. Okay. Thank you.
Yes. So a truly inspiring session from Professor Debzani. Deb, thank you so much for joining us today. And if you do have any questions, the audience, please direct them to her at her email address. And once again, we were truly honored to have you, Professor Deb, and thank you very much.
Okay. Now, next in our lineup, we have arranged a series of technical sessions for today's agenda. But as you are not required to come again to this auditorium, so we'll introduce all the technical sessions that are arranged for today and all the items in our agenda. So as the first set of technical sessions, we have a session on computer vision conducted by Dr. Kanika Vidanage and Professor Ashok Karunananda. Will be in 4th floor auditorium 2. And then an invited talk on exploration of advanced graphs and network in cardiology by Professor G. Mahadevan, the director of Center for Visiting Experts, Gandhigram Rural Institute in India. And he will be moderated by Dr. Buddhita Hettige. And the venue will be 4th floor auditorium 1. And that invited talk will be followed by a session on modeling and simulation by Professor G. Mahadevan, Dr. Bimali Jayasingh and Dr. Ramesh Tanuja, and venue will be 4th floor auditorium 1. And in addition to that, we are pleased to announce the ITRU mini symposium where you can present your work and explore the ideas of our inspiring professionals, and will be held in 2nd floor auditorium 1 by Dr. P. Jnana Chandra and Dr. D. Sasikala.
Following these sessions and the mini symposium, there will be refreshments provided in the open area. And right after refreshments, please join us back at this hall for our second invited talk of the day on Markovian queuing models with multiple working vacation, conducted by our guest speaker, Professor M. Srinivasan, Director in Charge and Associate Professor at Center for Distance and Online Education, Annamalai University, India. This session will be moderated by Dr. Buddhita Hettige.
Thank you very much.
Before starting the author presentations, I would like to cordially invite Professor G. Mahadevan to an invited talk on exploration of advanced graph and networks in cardiology. Professor Mahadevan is professor and the head of the Department of Mathematics at GRI, deemed to be University, Tiruchirappalli, and serve as the director of the Center of Visiting Experts and Professor of Practice, Center for Advanced Graph Theory and Network Sciences. Please welcome, Professor.
Outset, I place my sincere thanks to the organizers, Professor Sanjeev Ferreira and the head and the director, Talini Madam, for giving me the opportunity to say something about the applications of advanced graph technology in cardiology. Today's technical world scenario, everything is possible with the help of mathematics only. Whatever may be the problem that we are going to face is solvable. Only thing is we must know how to convert your physical or mental problems into mathematical language or graph theoretical language, right? Any problem, either physical or mental, that can be modeled as a graph by way of vertices and edges, right? By way of vertices and edges. Just I want to just by whatever may be the problem can be modeled as graph theoretical technology. Then with the help of the existing algorithm or new algorithm, you can apply it, get the result and interpret with that the physical situation. That is the beauty of mathematics. Because of its rich in application, nowadays almost all areas of mathematics are converged to graph theory. People are doing research in algebra, there is area algebraic graph theory. People are doing research in analysis, graph from analysis, graph from algebra, graph from topology, graph from differential equation, graph from fuzzy. Almost all branches of mathematics are converged to graph theory because of its rich in application. So due to shortage of time, just I want to tell only one situation where we use the concept of graph, especially in cardiology. Suppose you enter into the hospital without knowing you, without monitoring you, the doctor is not possible to tell what actually the problem is, right? Am I correct? Am I correct? So that's why I'm telling that doctor is not a god. Once you enter the hospital, without checking you whether the doctor is able to give that you have a heart problem, no, right? What we do is, he go for many another very tests, right? Based upon the report only, he can tell, he compare the existing result with the, he compare the result of your medical report, existing medical report, right? If the result exactly matches the existing medical report, he say that there is no problem at all. If the result deviates very long to the existing medical report, he said you will get a negative result, right? If the report is very near one, he can say, okay, no problem, we can go on bypass surgery as we use, right? Now, because of this routine application, almost all medical problems are solved with the help of graphs. Now, due to shortage of time, just I want to focus only one thing. You will keep, what is this? What is this? What is this? What is this? Heart. Men heart or woman heart? Men heart or woman heart? Men heart or woman heart? Say men heart or woman heart? Question mark. Both the hearts are same, right? Men and woman are same. Your heart can be modeled as a fantastic graph theoretical language. What we do is, your heart consisting of some 24 holes are there. Some many holes are there, right? And blood is flowing from one part to other part, right? So for example, the holes are the vertices. For example, aurora, pulmonary artery, pulmonary veins, left atrium, metal value, aortic value, etc., etc. These are medical terms, right? All the holes in your heart are the vertices. Are the vertices. If a blood is flowing from one part to other part, put an edge. Otherwise, don't put an edge, right? Inside your heart, blood is flowing in one particular direction only. If the blood is flowing in all the directions, the patient will get a ticket very soon, right? Right? That we don't know. That we don't know. It's a medical miracle, right? So the human heart can be modeled as a graph by way of vertices and the edges. How to draw a graph of human body? If the heart consists of many holes, holes are the vertices. If a blood is flowing from one part to other part, put a graph. Of course, it is a directed graph, right? For example, if a blood is flowing from aortic valve to pulmonary vein, you can join an edge, put a mark. If a blood is flowing from left ventricle to pulmonary artery, right, you can join an edge. In this way, you can obtain a beautiful graph theoretical representation of human heart. Am I correct? Am I correct? Similarly, your men anatomy and human anatomy can be modeled as a graph. Your body consisting of many bones and joints are there, right? If many joints and bones are there in your body, put joints are the vertices. Joints are the vertices. If a bone is connecting from one joint to other joint, put an edge. Otherwise, don't put an edge. Okay. For example, take a finger. Here one joint, other joint, other joint, other joint. Put a vertex. A bone is connecting from here to here, join an edge. A bone is connecting from here to here, put an edge. But there is no bone connecting from here to here, don't put an edge, right? In this way, you can obtain a beautiful graph theoretical structure of our men anatomy and female anatomy. Go to Google, type it, applications of graph technology in medical field. You will get excellent papers in SCA journals, Scopus Index or Web of Science or Springer, etc. Nowadays, even breast cancer can be solved with the help of graph theory. If cancer cells are vertices, if one breast cancer cell affects a nearby cell, put an edge. In this way, you can obtain a beautiful graph structure. After this, we have to, suppose the particular cell of a cancer cell affect the nearby cancer cell, we have to remove that vein, right? Remove that, so that this cell, this cancer cell will never affect the good cells, okay? Now, after obtaining a excellent graphical technology, we have to decide which edge has to be removed, right? Which edge has to be removed, so that the cancer will never affect the nearby cancer cells. So likewise, many excellent applications are there in graph theory. It is very much useful for the doctors to perform surgery. That's why I'm telling that doctor is not a god. Based upon the report only, he can decide. That report is based upon the mathematical background is only graph theory. Not only in digital medical field, but also in digital field also. Say University of Moratuwa is a very big campus. I want to safeguard the entire University of Moratuwa. Say, without knowing you, without monitoring you, each and every activities of the students of University of Moratuwa can be monitored by a person or management principal or HOD, whatever it may be, sitting in the flight. Is it possible or not? Without the physical presence, each and every activities of the students of University of Colombo can be monitored by the director Sanjay sir sitting in my university. Is it possible or not? Possible. How it is possible? CCTV camera, right? 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 A very big campus. Now the question is, if I want to insert one CCTV camera, I got to give more number, a huge amount of money, right? Now the question is, how many minimum number of CCTV cameras are required? Not only how many, where we got to fix, a really problem. How to solve the problem? Your physics and your chemistry never solve the problem. Mathematics, especially graph theory, has got fantastic solution to the real problem. What we do is, you convert this city map of University of Colombo or University of Moratuwa into graph model. You can, after converting this into graph model, there are so many existing parameters available in literature. Dominating set, connected dominating set, total etc. Different varieties of domination parameters are available. Depending upon the nature of the problem, You choose any one of the parameter, apply it, get the result, and interpret that with the physical situation. That is the beauty of mathematics. So whatever may be the problem, the same problem can be remodified as how many minimum number of cell phone towers are required in order to give hassle-free network to all over the world. How many minimum number of radars are required to safeguard our country? Our country, we are, suppose every country has faced a threat by nearby country. If your enemy's missile comes into your border, within a fraction of a second, your missile will go and attack, right? How many minimum number of sensors are required? How many minimum number of police stations are required? These are all really problems. All those problems are solvable. Only thing is, you must know how to convert your physical problem into mathematical language or mathematical modeling, right? Or graph theoretical modeling. Now come to this part. So this is the human heart. As I already told you, the human heart can be modeled as a graph by way of vertex and edges. So just I will show within 1 minute. I will show. You can, because of lack of time, I can skip all technical terms, right? For all technical term, clustering, coefficient, there are many technical terms are there. Due to lack of time, I can skip it. You can go to Google, you will get it. But here, say how to consider it more important, right? So there are many 24 holes in your heart are there. Say superior aneva, let it be V1, V2, V3, V4, etc. Pulmonary triangle, right pulmonary, right lung, left lung. So like that, so you denote the nodes. Okay, nodes are the say V10, V11, etc., V24, etc. Right? For example, if your blood is flowing from right article to right ventricle, you can put an edge is formed between V3 and V4 in the direction from V3 to V4. Okay, that's what I told, and that's why I'm telling that your human heart can be modeled as a directed graph, not ordinary graph. Okay, if your blood is flowing from one part to other part, put a arrow mark. Okay, so this is the technical terms of the vertices. If your blood is flowing from one part to other part, you can join an edge. So in this way, you can obtain a beautiful graph theoretical structure. After this, yeah, this is the graph theoretical representation of human heart, right? Say 24 holes are there, 24 holes are there, and arrow mark is there. Na? Say for example 18 to 24 arrow mark is there. That means what? Your blood is flowing from here to here, but there is no arrow mark from RA to IV, right article to this part. There is no direct arrow mark because what? The blood is not flowing. Are you able to follow me? Are you able to follow me? If your blood is flowing from one part to other part, you can put an edge. Otherwise, don't put an edge. This is the graph theoretical representation of a human heart. Right? Once you enter the hospital, that depends upon many echo, ECG, and after obtaining many manipulations, many algorithms are there. Depending upon the algorithm, first step is I converted our human heart into graph model. Again, I am going to impose many algorithms, some manipulations, some technical term. Again, after this graph can be converted into binary matrix, right? So this is using some algorithm, some manipulations. After obtaining this graph, I can able to get the graph like this. It's a 2x2 binary matrix, right? Not 2x2, 24x24, because heart consisting of 24 holes. No, so 24 holes are the vertices. So this is the binary matrix of the human heart. It varies from person to person. Now count the number of, again at this stage, again I got to impose some conditions, some manipulations, some calculations are there. After that, I can change or modify this into, again, another binary matrices. This is the binary matrix, right? Yeah, this is the binary matrix, right? Right? Say here, count the one which is inside the box. Tell me how many ones are there? How many ones are there inside the circle? Not ordinary one. The one within the black, within the red square. Count it. Count it. Is correct. You students, this scholar students tell. How many ones are there? Don't tell there are many ones are there. The one which is inside the red square. How many ones are there? Huh? 5. Right? So that one. So 1, 2, 3, 4, 5. right? There are 5 ones are there. So your heart consisting of 5 holes. 5 blocks are there in your heart. So this is a technology that the cardiology will decide. So just because of seeing your face, the doctor can never tell that you have a heart problem and you have some many blocks inside the heart. He can't tell. Okay. So that can be modeled as a graph and obtaining that many algorithms after getting just a result report. This report shows that your heart having 5 blocks are there. If the number of blocks is increasing very high, the doctor can suggest you can go for bypass surgery, right? If a number of blocks is very less, that is 1 or 2, he can tell that, okay, don't worry about it, you can put a stent. If a number of blocks is huge number, he can say, very soon you will take a ticket, right? Right? Right. So that's why I am telling that doctor is not a god. He can give some medicine, he can give some tablet, he can tell the decision, that's all. He is only the agent to communicate what is available in the medical records, right? Now, suppose here 5 blocks are there. Okay, the doctor decided to put a stent inside your heart. Okay, the patient entered the hospital, entered the operation theater. Everything is ready. The doctor came to the operation theater. Now, how he put a stent? That is another question. Just because of patient's face, okay, he is okay. So you can put the stent in any pot. Not possible, right? He must know the exact place in which the stent should be fixed. That can be decided again mathematics. The backbone is graph theoretical technology. How? Say, see that one. See the first one. This first one occurs in which row? First row, second row, third row, fourth row, fifth row, sixth row, right? Sixth row. At column, tell me, first column, second column, third column, fourth column, fifth column, right? So sixth row, fifth column. Am I correct? Am I correct? So fifth row, sixth column block is there. Okay. So in the monitor, there are so many technologies are there in the cath lab. So many technologies there. After obtaining the exact places, nowadays the robotics the doctor can able to identify the place in which the stent has to be inserted. Okay. So in the monitor, okay, the fifth row, sixth column. So inside your heart, they identify the exact places. In that place, they can put a stent, right? So that is a technology. So backbone of all medical field is nothing but graph theory. The only thing is you must know how to convert your physical or mental or your human anatomical structure into graph model by way of vertex and the edges. After obtaining beautiful graph, so many algorithms, so many manipulations are there. Take the report, take the report, right? Based upon the report, the cardiology can compare your medical report of the heart into existing medical report, right? Now he can compare, based upon that he can give a treatment, either go for surgery or give for medicine. Not only heart problem, even I already told breast cancer, even abdomen cancer, even brain, your human brain has excellent machine, not excellent machine. So human brain is the topmost genius part. Today I may be a good friend of you. Tomorrow I may be a bad friend of you. Why? In between that one day, you can know many things about me, both in good sense as in bad sense. Immediately your brain will change. If neurons in your brain smash like anything, immediately you will change. Even the graph theory has got fantastic solution for solving this neuron-related problem also. Right? So, lack of time, I think with this I can stop. So this is again just another 1 or 2 minutes I will show some of the slide. So slide is not working. Oh. And similarly, our human brain, likewise, yeah, see, this is our human brain, right? Your human brain consists many areas are there. In brain consisting of so many areas are there, right? So regions are there. Put the regions are the vertices. Put the regions are the vertices, right? So orange, yellow, red, blue, or regions are there in your brain. The regions as a vertex, right? In your brain consisting of many areas are there. Regions are the vertices. If a communication is possible from one region to other region in your brain, even the same thing like a heart, even inside your brain, the cells and the neurons can never pass a signal from in a random wise. In a random wise, the signals are passing, and then the patient is a coma stage or something else, some mental something else, right? Am I correct? So inside your brain, the neurons or communication should pass us in a particular direction only, particular way only, right? So how to convert your brain as a model as regions are the vertices? Are you able to follow me? Your brain contains many regions are there. Regions are the vertices. If a link or a communication or something, neurons or protein interaction, protein gene interaction, protein metabolic interactions are there from one region to other region, put an edge. Say in this way, it's a complex network. The brain has a complex networks. Okay, this brain is a human body. This is the graph theoretical representative human brain. It's a highly complicated networks. Of course, arbitrary, we cannot find a graph theoretical human brain. It is very difficult. It's an NP complete problem, right? So after converting this into graph model, you can bifurcate, you will get a graph. That is why ECG, not EEG, not ECG. EEG, brain scan is there, no? For heart scan, we can tell ECG. For brain scan, EEG, right? I will show you. So, even brain problem, the doctor, the neurologist can tell what is the problem in your brain, again based upon the report only. Once you enter the hospital, neurosurgeon, just because of seeing your face, the neurosurgeon can never tell you have a mental problem, right? Right? No, don't mistake me. Okay. You don't, we cannot say. Okay, based upon the report, that report based upon the graph theory. The backbone of all medical report is graph theory. Just I will show one or two slides, right? So see, after this, yeah, see, the first one is our human brain, right? Right? Are you able to follow me? Clear? First one is human brain. That can be, we put it as number one, right? And it is bifurcated into two. That is here 1, 2, 2, right? So that the red code is first human brain. It is bifurcated into two. So here, again by historical or imaging data, anatomical parallelization, recording sites, time series data, network analysis, functional by network, structural by network, like that. So your human brain can be bifurcated, trifurcated, decomposed into many things depending upon the situation. Right? First one is a brain. It is bifurcated into two, again two. At last you will get a graph like this only. Say any neurosurgeon, go to any neurosurgeon, you can discuss, you can have a report of your brain. It is just like this only. Am I correct? Am I correct? Your brain report is like this only. Now the cardiologist can know, even the neurologist can know what type of disease this one and how to cure, how to give a proper medicine, or if a block or something is there, how to remove that can be decided. So what I want to communicate with you is even a human brain has got excellent application in graph. The backbone is mathematics. The backbone is mathematics. Not only human brain, even blood cancer. Go to Google, type it, applications of graph theory in blood cancer, not breast cancer, even blood cancer. Very simple, your anatomical structure can be modeled as a graph by way of what it is. Depending upon nature of the problem, you can apply it to 1 minute. just one minute. Depending on the nature of the problem, you can apply it, get the result, and interpret that with the physical situation. That is the beauty of graph theory. So, in a nutshell, again, I will show. This is one. The next one, even a knee replacement. Again, we are going to use the concept of graph theory. Yeah, how to replace our knee based upon the backbone is again a technology. Yeah, in which part we have decomposed. Your human knee can be modeled as a graph. Then how many parts are, how many nodes are removed, how many edges are removed, so that knee can be fitted. That is backbone is graph theory. Likewise, still lot of openings are there to do research in graph theory. Only thing is you must know how to convert your physical or mental problem to graph. So only due to shortage of time, time is very limited one. So with this I will stop. Before that I want to say only one thing. Whatever may be the problem, physical, mental, job, marriage problem. Marriage is a very big problem. Even that problem can be solved with the help of graph theory. So a set of boys are there in a college or school. Put boys are in one set, girls are in other set. If a boy has some girlfriend, put an edge. If a girl has some boyfriend, put an edge. If a girl has no boyfriend, don't put an edge, he is happy. If a boy has no girlfriend, no problem, don't put an edge, he is the saddest person in the world. Okay, whatever it may be. So in this way, you can obtain a beautiful graph structure. After obtaining a beautiful graph structure, we are in the world, Indian system. Now in India, a person has to marry only one girl. I don't know about the Sri Lanka, right? So after obtaining this, a boy has to marry only one girl among his girlfriend, not other girlfriend. If a boy has 5 girlfriends, the boy's fate is he has to marry only one girl among his 5, not others, right? So under what condition they got to marry to run a peaceful life? After marriage, there is no peaceful life. Okay, but under what condition they got to marry? That can be decided by graph theory only. So with this I will stop. So likewise, whatever may be the problem is solvable. Only thing is you must know how to convert your physical or mental problem to graph theoretical language. Okay. Then there are so many algorithms out there. Depending on the nature of the problem, choose any one algorithm, apply it, get the result, and interpret that with the physical solution. That is a bit of. Thank you very much for your patience. Thank you.
Thank you, Professor, for your valuable speech. And now I would like to invite the session chairs for the track 7, Modeling and Simulation, the session 12 of ICITR 2025. Professor G. Mahadevan, Director, Center for Visiting Experts, and Professor of Practice, the Gandhiram Rural Institute, India. Dr. Bimali Jayasinghe, Senior Lecturer at the Faculty of Engineering, University of Moratuwa. Over to you, sir and madam.
Good morning, everyone. Good morning, everyone. I'm Lakshana Vikram. So, good morning, everyone. I'm Lakshana Vikramasinghe. So today I'm here to talk about our research, Red Piranha optimization with adaptive search space. So I would like to acknowledge my co-author, Dr. Kushananda Silva. So this algorithm is one of the algorithm from family of swarm intelligent optimization algorithms. Why we use these algorithms? Actually, there are many real-world application problems, complex optimization problems that we cannot solve them using very easily. But we have observed that some of the animals actually collective behaviors from like elephant herds, bird flocks, ant colonies, bee colonies, they solve them these kind of problems very easily in their day-to-day life. So we take these strategies into algorithm and we develop algorithms to solve complex optimization problems. So in this research particularly, we selected piranha strategies to do the optimization because their aggressive and cooperative behavior has support to increase the balance between exploration and exploitation. Among the few algorithms existing Red Piranha algorithms, we have selected Red Piranha optimization algorithm, which was introduced by Raby and Sal. Because this algorithm is a very simple algorithm with a limited number of parameters. This algorithm consists with three sequential phases, and these three crucial phases, they balance exploration and exploitation very effectively. Actually, in the first phase, they only focus on exploration, and when they come to the second phase, they perform both exploration and exploitation, and in the last phase, they're solely focusing on exploitation. Even though this algorithm is developed balancing the exploration and exploitation, we could observe that when we run the algorithm and get the outcome, for example, we have visualized the outcomes for the Bailey function here. As you can see, if we take the global optima as shown in the red color dot, and if we take circles with radius 0.1 and 0.5 around this global optima, out of 50 independent runs, most of the outcomes has failed to come inside the red dotted circle. So if we take one of the independent run and take the simple regret for each iteration in this independent run, we can observe that for the first two phases, it has given us the expected outcome. However, for the last phase, it is in a steady state. But our expectation in the last phase is exploitation. That is, we need to enhance our obtained objective value more toward the global optima, but it hasn't done here. Why this occurs? The reason is, in the last phase, there's a special scenario called solution collision. When we are in this last phase, when we move toward the prey, there is a risk, there is a possibility of losing our because of the crowding, there's a risk of losing our potential solution. To avoid this, they have introduced a parameter called safety shield, and if any two search agents are too much closer than twice this parameter, we move the search agent with the least objective value, worst objective value, to a new random location anywhere in the search space. Because of this, there's a risk of, because of this dispersion, the direction, it misleads the direction of the exploitation, rather exploiting the area of optimal solution. So to avoid this avoid this scenario, what we have suggested it, now we have suggested a new escaping area which is focus the best objective value in the current iteration. So this escaping area is centered at the global best objective value in the current iteration, and it has theta, a radius of theta. This theta is dependent on the current iteration number and the size of the search space. So by the iteration passes, this escaping area is shrinking, increasing the focus to the current best objective value area in the search space. So to analyze the performance of our algorithm, we have used two matrices, which is precision and the absolute error of the best optimal solution and the global optima. Our main focus is precision here. So in the precision, what we are taking is we calculate how many of the obtained solutions will fall within the circle of a defined radius centered at the actual global optima out of 100 independent runs. Here we have taken radii as 0.1 and 0.5, and then we compare the results with our original algorithm. When it comes to the absolute error, what we are doing is we take the difference between the best objective value out of 50 independent runs and the global optima. Then we compare our results with CME-ES algorithm and the original algorithm. So in the precision analysis, we have tested this algorithm on 23 benchmark functions, and as you can see in this bar chart, for the most of the benchmark functions, our modified algorithm has success to increase the precision or preserve the precision it was before. But there are for two of the functions, there are minor drawbacks. This happens because our population size is fixed, but when it comes to a larger search space, there are slightly drawbacks we could observe. So if we run our algorithm for 15 independent runs, again for the benchmark function we took previously, now we can say we have outperformed the issue we had previously. Actually now out of 15 independent runs, most of the outcomes has succeeded to reach the global optima, and in the simple regret as well, in the phase 3, now as you can see, it has enhanced its objective value more toward the global optima by the iteration passes in the phase 3. When it comes to the absolute error, out of 23 benchmark functions, this modified algorithm has given the least error to 18 of benchmark functions compared to the original algorithm and the CMA-ES function. And as well, modified algorithm has given 0 errors to 14 of the benchmark functions. So as the conclusion and the future works, we can say that in this study, overall, this algorithm has increased the precision, significantly improves the precision for the unconstrained benchmark functions, achieving up to 190% precision increase for the most critical radius of 0.1. And we noticed that there was minor drawbacks because of some fixed parameters. So as the future works, we expect to analyze this adaptive parameter settings, adaptive parameter control under different parameter settings like population sizes, dimensions, such as. So as well, we try to add a population diversity mechanism. Here we have only considered population size of 30, but in the future we try to test it in population 10, 30, 100, and so on. Also we try to give a strong statistical analysis for our algorithm with compared to the existing other algorithms like particle swarm optimization and ant colony optimization. So this is the reference I have used to study about Red Piranha optimization original algorithm, which was introduced in 2023. So that's all about my research. Thank you for listening. I'm open for any questions you may have.
indication in that one. How
Uh,
do you say that your model is the best one?
actually,
I'm not disgracing you, just I'm
yeah,
asking.
yeah.
How do you say that your model is the best one? You are claiming that it is the best one. Yeah.
Actually,
In your paper, you are claiming that our model is the best one, like that you are mentioning. If that is the case, at least you mention something that I compared, even though you compare on a different area. I compared this with some other model, I got this. Like that, some word, some point should be there. Then only it is meaningful, right? Now you tell.
when it comes to the other optimization algorithms,
Give some summarization, huh?
uh, I have tested this algorithm with compared to the CMES function currently. With the CMES functions, our best solution and the runtime. I haven't mentioned the runtime because I was only focused. Yeah, I only in this paper I focus in this stage I focused on the precision. Yeah. Okay.
Now you are
Sure.
trying that you compare with some other technique. That it should be in your paper.
Yeah.
Any more questions from the audience?
CME's function is it is an actually it's an meta-heuristic algorithm, meta-heuristic optimization algorithm. Red-Piran optimization. Uh, I I am not I cannot actually give the thank you, sir.
Thank you for nice presentation. Fine.
Thank
Thank you. Next, I invite the AI-aided financial analytics dashboard for high frequency traders. Yeah, please. Silva, Sanjeev Ferreira, Udaya, and Hasida.
So, hi everyone. So, I am Mudari De Silva on behalf of the Center for Mathematical Modeling, University of Colombo, Sri Lanka. So, and this is a joint work with Professor Sanjeeva Pereira, Dr. Prabhat Liyanage, and Dr. Hasita Erandi. So, we developed an AI-aided financial analytics dashboard for high-frequency traders. So, let's get into our work. So first of all, about high-frequency trading. So it is an ultra-fast automated trading system that executes thousands of orders in milliseconds. So it operates in specialized low-latency environments. And you know, the key thing is the speed. So whether you earn a lot or you lose a lot depends on your speed. So in the early stages of our work, so we identified 3 blind spots in current financial analytics in this domain. The first one was that high-frequency trading was always considered as a time series. So it was always about variances and means. So we saw this as a blind spot, so nobody looked at it as, about the structure, the shape of the market, so these things were not discussed. We saw this as a blind spot. The second one is volatility is not a single quantity, so it has perspectives. So volatility can be backward looking, the realized volatility, and it can also be forward looking, the implied volatility. So it can be the volatility structure, it can be different states of volatility. So like volatility has different perspectives. So this was often overlooked in the research. So we saw this as a blind spot. The next one is, so suppose this volatility is the wideness of a wave of the market. So we need to know this, where this wave is moving and whether it is accelerating or decelerating, the velocity aspect of a market. So this was also overlooked in most of the research. So to answer these, to fill in these gaps, we came up with an intelligent system. So our system has 3 sensors, we can say. So we are trying to capture the structure of the market, the shape of the market, and we are trying to capture the expectation of the market, the fear, the psychology of the market, and also the kinetics, so how the market is moving. Okay, so to answer the first one, we came with this advanced volatility panel, and our first output is a traffic light system. I'll explain. We have used topological data analysis, hidden Markov models, and also anomaly detection. So the next one is a volatility surface. So we have classics, the Black-Scholes model and all. So this also includes RBF interpolation, that is the radial basis function interpolation. And to answer the expectation, the market expectation, we have the volatility panel. So this one is a bit simple. We have 3 models, the realized volatility model, implied volatility, and a price-based volatility model. We have XGBoost and LSTM. And then to answer how the market is moving, we have our speedometers. This is something very new. So one of it is the price speedometer and the volume speedometer. So this is a lightweight tuned XGBoost model. So that is because of the dashboard is real time. So yeah, so our dashboard is run on Streamlit, and our data sources come from Yahoo Finance and Alpha Vantage. So let's go into the outputs of the main panels. So here you can see a traffic light. So you might wonder why we are trying to explain something as sophisticated as volatility regime switching using traffic lights. But the idea is simple. So our human psychology is very attuned to the colors of a traffic light. Red means a threat. Green means we are safe. Those kinds of things. So that is how a trader responds to volatilities. So high volatility is something you should be cautious about. That also has different transitions. So that's it. That is the concept of this traffic light system. So we are trying to tell something very complex using a very clean interface. So if somebody is panicking how we get into the final answers, you can enable these options as well. So we are giving the scatter plots and the detailed matrix and even the TDA persistence diagrams. So our main use case of this is we are trying to manage the risk. So I hope you understand the way we should respond to a high volatile situation, and a low volatile situation is entirely different. So this is all about strategizing. So this is the user case. And next we are going to volatility surface. So this is about option pricing. I hope you know that options are priced based on fear. And in markets, there are 3 types of fears. So the first fear is about the expected risk, the implied volatility. The next fear comes based on whether we are winning or losing, and that is moneyness. And the third fear, there's a third fear which comes with time. So that axis, we have time to expiry. Now we have 3 fears, 3 axes. So if we bring them together, we get the volatility surface. So the best thing about my dashboard is that I have given you many kernels. So whatever your situation in high frequency trading is, I have a kernel. So you can get the support. So that's something very new from the traditional ones. And I have given many filtering options so you can smooth out your surface, and you can get the 2D slicers to understand the skews and the smiles as well. So this is mainly about hedging, the strategizing part. and also you can price your derivatives based on my volatility surface, and this is the main idea is risk management part. So these are the some snapshots of my speedometer panels. So you can see this is also something you don't have to analyze anything. I have given you the velocity, and I have given you whether the direction is bearish or bullish. So the idea is, so the two ideas of the speedometers are, so the stock price speedometer is about momentum based strategizing. So based on how the market is moving, you strategize. The best part is the stock volume speedometer. It is something very different. So it helps you understand the hidden details. So the market sentiment, the emotion of the market. So whether someone is secretly selling, whether someone is secretly buying, so whether hidden activities. So it's very good. So it's something emotional about the market. The next one, so I am not going to for the time being, I'm not going to discuss this in deep, but yeah, in evaluating our model, in backtesting, we went very far, we came a long way. So we went with most of the academically accepted ways. So the final part, so now that we have our 3 panels, we are bringing all of them together. Now we have a unified dashboard. So now this solves the fragmentation problem of the traditional dashboards. So in traditional dashboards, it's either the volatility, it's either the speed. So so in our case, we bring many ingredients that can come to a collective decision about the markets. And we have a hierarchy of intelligence. We have a foundational layer, some maths and machine learning, and then we have the analytical models we discussed, and also the interpretation layer, and this is where the AI part comes in. We interpret everything for you. And the best thing about the model is, the dashboard is, you can cross-validate, you can cross-check between the panels. So whether the decision you are getting into with the speedometers are supported by the traffic lights. Like that, you can cross-check. So to end my presentation, so I want you all to know, so what are the new things and original things in my dashboard, in our dashboard. So one of them being that we give you a volatility surface with many kernels. So whatever your HFT situation is, we have an answer for you. The second one is, this is something entirely new. So we are adding topological data analysis to the regime switching model, so we understand the shape of the market as well. So the last one, we are coming with a divergence-based speedometer, not just a simple speedometer. So that is our work. So these are the references we used in our paper. So that's it. So thank you, everyone.
Any questions from the audience? Okay, I have only one question for you. You have taken data from the New York Stock Exchange.
Yeah. Yeah.
On the website.
So the
Authentication one, whether you have the permission to include it.
my data sources are Yahoo Finance and Alpha Vantage. Yahoo Finance and Alpha Vantage. So all the experiments were done.
You are telling in one page the stock data used in the experiment were drawn from the New York Stock Exchange.
Yeah, those were the examples.
Case, you have to mention that New York Stock Exchange is the reference. You mentioned it. Say you are taking data from the website
Yeah.
or something in stock exchange market. Okay?
Yeah.
If that is the case, you have to mention that website or that particular information to your reference.
All right. Yeah.
It's not there.
So this is done using the Yahoo Finance library.
Maybe
It is included. Yeah.
under Yahoo Finance,
Yeah.
this is the words. In the paper, you clearly mention, I will read it. You clearly mention the stock data. I'm not telling you, this is your paper.
Yeah. Yeah.
Stock data used in the experiment were drawn from the New York Stock Exchange.
Yeah. Yeah.
Put the word like this.
Yeah. Yeah. Yeah.
But whether you are taking from data from website,
Yeah.
that citation should be there in the reference. Or in that itself, within the bracket you want to mention.
Okay.
Otherwise,
So-
plagiarism.
Yeah.
I'm giving suggestion only.
Okay. So I want.
Positive sense.
Okay.
You are taking
Hello everyone, I'm Kavisha Gimhani and on behalf of the Center of Mathematical Modeling, University of Colombo. Before I start my presentation, I would like to thank all my co-authors for their guidance and their help in this research. So today I'm honored to present my research about physiologic-based landslide susceptibility mapping in the Kaluganga Basin area of Sri Lanka. So with the past few incidents happening in Sri Lanka, we all understand how much impact that a landslides can cause for a Sri Lanka.
Because of the landslide, you put a paper, huh?
No, before that,
Because of major natural problem, she make a paper, fine.
so it is causing a huge damage to the people infrastructure, also for the economic. So for this national lead, and I understand there is a bigger research gap that for an area like Kaluganga Basin, which is more frequently occurred from landslides, have no recent and detailed landslide susceptibility map. NBRO has presented their landslide maps, but they are now outdated because they are happened in 1995. Also, some other researchers has done for the districts like Ratnapura and Badulla districts, but they cannot be fully adopted to the Kaluganga Basin area due to the unique region geological factors that has incurred in the Kaluganga Basin area. So the objectives of my research were so simple. I first want to identify what are the major key factors that will affect for the Kaluganga Basin area to create landslides, and I want to design a landslide susceptibility map which they can capture these uncertainties and complex geological features. So, as I explained earlier, Kaluganga Basin area is one of the major landslide-prone areas in Sri Lanka with a heavy rainfall, which is a main triggering factor for the landslides. And also, it is a highly populated area. Most of the people are living in these landslide-prone areas, so this could affect a very big problem for their lives, damages, and etc. So I choose physiologic to implement my methodology because physiologic is one of the biggest models that have identified that can capture more uncertainties than the traditional methods like logistic regression. So even for the areas that we have insufficient and inconsistent data, we can combine it with GIS and fuzzy logic because fuzzy logic is more efficiently work with these GIS formulas. So when I'm doing as my data set, I choose previous landslide occurrences in this area. I choose 124 landslides. When I'm training my model, I get 99 data as my training data set and 25 data for my testing data set. I did this research with collaboration with National Building Research Organization. So from their guidance and my own literature review, I identified 7 key factors that will affect for the landslides in this unique area. They are slope, slope aspect, slope elevation, land use and land cover, drainage density, road density, and topological wetness index. So coming back to my methodology, first I collected my data from NBRO and more online resources like digital evaluation model, drainage density, and road density likewise. Then I pre-processed these data using QGIS application, and I classify these maps to natural Bayes methods to obtain for future steps. So after that, I use frequency ratio analysis. From this analysis, I would be able to compare how often landslides happen in a specific class and how much of area that class covers. So after that, getting these frequency values, I convert them into fuzzy membership functions by normalizing them into 0 and 1. In there, I use my fuzzy method with fuzzy overlay method with fuzzy algebraic product, fuzzy algebraic sum, and fuzzy gamma. So in order to obtain what is the optimal gamma value, I developed 10 suspectability maps varying gamma values from 0.9 to 0.99 and find the final optimal value from model validation. In there, I used accuracy, area under curve, recall, and F1 score to identify. So if I talk about my results, in doing frequency ratio, I identified that slope is a dominant factor that affectly more into the occurring of the landslides in this area. So also high road density is another factor that giving examples that human activity is more involving to the occurrence of landslides. So in this, for more confirmation, I did feature importance for landslide suspectability map with random forest. In there, it confirmed that slope and elevation is the most prominent factors that help to occurrence of the landslides. So in there, I identified one of crucial results. So terrain factors are influencing in landslides more than the hydrological and environmental factors. Other than that, I did sensitivity analysis to identify when there is a higher steep, the occurrence of the landslides probability is getting higher. So slope is sensitive in more higher levels, and there is, when there are land use, in the more there are trees, then there is a more probability to happening the landslides. So when it comes to the, then I developed, as I explained earlier, I developed 10 landslide maps, and in there I did model matrix and with recall, accuracy, precision, recall, and F1 score. So I developed it through these 10 maps, and I get my optimal value at 0.95 optimal gamma value. So in there, I achieved higher AUC of 0.877 and more accuracy with 0.78. And also it occurs the 98% of a recall, where the model can obtain 98% of landslides correctly. So as you can see, when the gamma values is getting higher, there is a overfitting, and they are flagging non-landslide areas also as landslide areas, which makes them very wrong. So if I come to the conclusion of my research, even though this model performs better, this could be more better with if I could include more data to geological characteristics about soil compensation, distance to roads and rivers likewise. And also I recommend this future work for, we can do this for flood suspectability and for all other regions. And also if we can implement this with fuzzy logic with neural networks, the results will be much prominent and can have more accuracy. So that's about my research, and thank you. I would love to hear some questions from you.
Thank you very much for your nice presentation, but I have one question under the input factor for the model, but I did not see the rain density. amount of rain per a
Yes.
certain area?
There are two factors that occurring for the landslides, the causative factors and triggering factors. Raining is the triggering factor for occurrence of the landslide. So we cannot define rainfall when we are predicting a landslide susceptibility maps. We are only going with these already they are in the place, there are already these factors are available. If these factors are available in this place, then when there is a rain, there is a definite probability that this place should go into the landslides.
Yeah, that of course. Then our question is, what is the amount of rain? These are the main factors. That of course, once then if you say example, 100 millimeter per that area, or then another time then 200 millimeter per that area, then what is the vulnerability? That means either first one or second one, or then how do you relate with this?
I actually didn't go for that far, but I have this, if these factors in my susceptibility map, there are areas that has a high susceptibility. So even with the low rainfall, there will be a chance that these places can occur landslides other than the areas that has flagged as greener parts. So that's the case, and that should be a good example that we can do future adaptations of this research.
Thank you.
ROC curves by gamma values we put it now on graph, page number, last page. Yeah. The graph is drawn by either MATLAB or something.
Sorry?
You obtain a graph now. Using MATLAB or something else. It's not a manual one. Which software you used that one? For drawing this curve, which software you used?
I use Python.
Python. Yeah, that's what I asking. Not MATLAB, huh?
No.
Okay, fine. Because MATLAB, this type of curve is not possible. That's why I'm asking. Okay. Thank you for nice presentation. Thank you. Now we invite a kinetic theory based approach to modeling dengue transmission. Hansika. You are a full-time scholar, eh? Yeah.
Hi everyone, I'm Sandali Hansika from University of Colombo. So this is my research project, a kinetic theory based approach to modeling dengue transmission. So we already know dengue is a major public health issue in tropical countries and subtropical countries, including Sri Lanka. So as you can see in this picture, it shows very clearly. So these outbreaks are very strongly influenced by climate factors such as rainfall, humidity and temperature, as well as human behavior. So most of the classical compartment models, they are fails to capture the individual impact of the dengue transmission. In here we are developing kinetic model to capture the individual impact of climate, human mosquito density. So when we are moving on to the objective, we are studying in this research project, we are build a dengue transmission model to capture the individual impact of dengue transmission by using climate factors and socio-economic factors. So in the methodology section, first step is data collection, and next we are analyze the data, and next we are developing the kinetic model, and finally we are predicting the dengue transmission. So the first step is data collection. In here we choose CMC area in Sri Lanka as our study area, And when we moving on to the climate factors, in here we use rainfall, land surface temperature, and when we check the correlationship between climate factors and dengue incidence, we can see that there is a 7-week lag and 12-week lags. And also we use social contract distribution to study our model. In here we use gamma distribution for that. So we developed 2-dimension IR model. Here you can see using equation 1 and 2. So those are the key parameters we use in our model. So when we considering our model, per capita vector density is the most important key parameter. To estimate the per capita vector density, we use fuzzy inference system. So we want to capture the combined impact of climate factors and socio-economic factors. In here, this is the process of fuzzy inference system. Here we use input as climate factors with time lags. In here, those are the steps we use in fuzzy inference system. So finally, we get the per capita vector density as our output. So another special key parameter of our kinetic model is social contract distribution. In here we use gamma distribution for that. So you can say it's described in equation 3. In here A is the shape parameter and B is the scale parameter. So this is the result we got from the kinetic model. Here you can see there's a little difference between 2020. The reason for that is COVID-19 season. So in our model, we only capture the climate factors and the human behavior, not only the human mobility. So in here, you can see the reason for that is it's restricted in our model. So as a future work, we can use to develop our kinetic model using human mobility. So as a conclusion, we can say human behavior and the climate factors are most strongly influence the dengue transmission. And also you can see we can capture the seasonal patterns of dengue in CMC area. So finally, this approach will help to improve the warning and support system for health planning. So those are the few references I used to this study. If you have any question, it's time to ask. Thank you.
Question from the audience, most welcome. Why you take only for dengue? What about the corona? You can make it a paper for corona.
Still not, sir. We are developing
in
the.
Sri Lanka there is no corona. Huh?
Sorry, sir.
In Sri Lanka there is no corona. You know the corona fever?
Yeah.
You just to replace the word dengue by corona, you will make it another paper.
Yes.
Am I correct?
Yes, sir.
Okay. You draw a Colombo Municipal Council area map.
Yes, sir.
Is it Python?
No, sir. It's
Software,
using
software you use?
QGIS.
Where?
QGIS.
Q?
GIS.
QGIS. Then another one is one more. All graphs are from QGIS only.
No, sir. The final graph I plot using Python.
Final graph is using Python. Oh, that's fair. Okay, fine. Thank you. Okay, thank you very much for a nice presentation. You make it another paper. Okay. Just to replace the word dengue by corona and some slight modifications you can do. Nothing wrong if people are doing like only. Nothing wrong in it. You may get some different data. So not for joke, serious I am telling. You may get some different data. Something new, right? Because in India we are doing like that only, research only. You take one paper, remove the word, put it some other word, you will get it. Nowadays technology has more advanced. Take a paper, download it, remove the other paper, put your paper, make a PDP, you can publish it. Okay. Okay. Huh? Okay. அதெல்லாம் முடியாது. இப்போ plagiarism வந்து there are so many softwares are there. Okay, thank you very much for the listener as well as the presenter for your patient hearing. Okay, thank you. And I want to place one Only one thing. In India, during March 27, 28, 29, there is an international conference organized by me in our university. All are most welcome. It is an international conference on reverberation of applied mathematics in artificial intelligence and medical millennium. I can bring all mathematics, computer science, and medical in one umbrella. All Sri Lankans are most welcome to India for this conference. Thank you. And the outcome of the conference may be published in Springer, Taylor and Francis, and the AAP, and one more journal suggested by Professor Srinivasan sir. We are in the process of getting approval from the journal. Definitely we will be able to publish. Springer free of cost, we will publish. No, don't worry about it. But it will take time, but free of cost, okay? So if anybody interested, you can send your papers. I will give my pamphlet to University of Morato and the University of Sri Lanka. You can take the consult with your guide, you can submit a paper. You are most welcome. You are most welcome to India, or through online you can present, right? Thank you.
Thank you, sir, and our presenters. Now it's time for the certificates distribution. I cordially invite Professor G. Mahadevan to join with us. Yes. Miss Lakshana Vikramasinghe. Miss Udari de Silva. Thank you, sir. I would like to invite Dr. Bimali Jaisinghe to join with us to the distribution of the certificates. Miss M. Kavisha Gimhani. Miss A.W. Sandali Hansika. Thank you, sir. Now I would like to invite Dr. Chandi Sharma to present the token of appreciation for our session chairs. Professor G. Mahadevan. And I would like to invite Dr. Bimali Jaisinghe. Ma'am, please, Professor, we have another special token of appreciation for your valuable speech. Okay, this remarks the end of the session 12th of ICITR 2025. Thank you all.
About to start the next invited talk in a moment, but if you haven't get your refreshments, they are available in outside of this auditorium. You are cordially invited to have. Thank you very much.
I would like to welcome all to track 7 modeling and simulation session 14 of ICITR 2025. And also I would like to welcome our session chairs for track 7 modeling and simulation session 14 of ICTR 2025, Professor M.C. Nivasan, Director in Charge, CDOE, Annamalai University, India, Dr. L.P. Sudat Rohit, Senior Lecturer, Faculty of Engineering, University of Moratuwa. Over to you, sir.
Good morning, everybody. I'll kindly invite the first presenter and presentation paper topic, forecasting urban air pollution in Sri Lanka using GARCH models for the effective air quality management. Now it's time for your presentations.
Hi, good morning everyone. I am DMSK Madhuvanti. I will be presenting on my research forecasting urban air pollution in Sri Lanka using branch model for effective air quality management. My other team members are Dr. ITS Piyathilaka and Dr. HCY Jayathung. These are the outline of my presentation. And first of all, I will give the short introduction about the air pollution. As you can see here, air pollution has become one of the most persisting environmental problem in the health issues. So here you can see the lead in several health issues I mentioned in this slide also. The pollutions can enter our lungs and our even bloodstream, so it is very huge health issue for our human health. Now, if we expose to these pollutants for the long time, it's linked to higher mortality rates, lung cancers, and other serious diseases. It may not seem like a big problem, but this is a very huge. Problem in the human health. So, continued investigation is very important to improve the air quality management. Then this is the background of my study. In the first study I mentioned here, N.S. Samras and the team established NBIN branch as the most accurate predictor for the particulate matter in the Sarawak, and the KC Yahoo and second study, and the KC Yahoo and the team demonstrated that integrating branch-based volatility term improved the accuracy of GSVM forecast for the PM 2.5 pollutant in the Taiwan. And other two studies and other two researchers suggested the hybrid neural network model and suggested the hybrid model with combining the statistical model and the machine learning model and deep learning model in here. This is the aim and objective of my study. The aim of the study is to apply the branch model to forecast particulate matter levels in Sri Lanka and provide insights to the improved air quality management. And here I mentioned two objectives in here, addressing the time varying variance in the data and provide insight for targeted strategies to mitigate air pollution in Sri Lanka. To best of our knowledge, there is no any research, there is no any application to forecast air quality models in the Sri Lankan context using the branch model. So I hope to fill this gap in this research. Now here, summary of the data collection and the study area for my research. I mainly focused in the Battaramulla area. The data was collected from Air Resource Management and Monitoring Unit in Central Environmental Authority in Sri Lanka, and I mainly focused two pollutants in here, such that PM 2.5 and the PM 10 concentration in the period of 2020. Now you can see as a table the summary of the data collection and study area of my research. Here I collected the data in the daily concentration data for the pollutants, both PM2.5 and PM10. Then I discussed the results as this slide. We observe variation of the particulate matter concentration in this plot. It is the time series plot. Here mention the red color in the PM10 pattern and the blue color PM2.5 pattern. Consider these two patterns, we can suggest that this data changed over time. That means this original data set is the non-stationary data set. But we can't apply any statistical like branch model without non-stationary now for the non-stationary data set. So first of all, we want to handle this data as a stationary time series data level. Then here I mentioned the statistical data summary and the stationary assessment in this table. The mean skewness and kurtosis I mentioned as the statistical data summary, and here I mainly focus the ADF p-values in this table. ADF means that it is the augmented Ducky-Foley test, I also known as the unit root test for this. This is we use for this to check the data set is stationary or not. We check it using the ADF test. Here consider the p-values for the result for the ADF test. Both p-values are greater than 0.05. That means our original data set is not stationary. It is non-stationary data set. It is confirmed our previous time series plot results in using this p-values. And after the first differentiation, again I apply the ADF test. Here as a last column, I mentioned these p-value 0.01. The both are equal to 0.01 for the both pollutants. This after the first differentiation, the both p-values are less than 0.05. That means after first differentiation, my data set became a stationary data level. Then I apply the Lagrange multiplier and the arch test to check the volatility effects. Here probability, you can see here the probability values for the PM2.5 and PM10 concentrations. All p-values are less than 0.05. That means there is an arch effect for the both data. So if it is an arch effect for the both the data, then we can apply the branch application for our data set. Now this is the results for the Gauge 1-1 estimate and the residual diagnostic. Here I mentioned the results for the Gauge 1-1 estimate in the first three columns, omega, alpha 1 and the beta 1. Omega is the constant for the Gauge 1-1 model and alpha 1 is the arch, represent the arch effect, and beta 1 represent the Gauge effect. And here last two columns mention the junk box p-values and arch p-values. These all p-values are greater than 0.05. That means there are no more any arch effect after the branch application of the branch 1-1 model. Then here I mentioned the alpha 1 plus beta 1 values. It's approximately equal to 1 for the PM2.5 data concentration levels. Then it is approximately equal. That means we can consider it has a high persistent, and we consider the PM10, it has the here alpha 1 and beta 1 less than 1. So it is covariance stationary condition, and we can call that it is low persistent volatility. In these two results, we can confirm the half-life measure equation. In the right hand side, I calculate the half-life measure. It is for the PM2.5, it is equal to 21.4. That means its mean in volatility decays slowly. And consider the PM10, the half-life is 1.48 days in the PM10 concentration data. Then it is indicating the faster decay of volatility shock. Now, these two results confirm the previous one. Here you can see the actual and the branch prediction for the both pollutants. These two are, there is no huge difference for the actual value and the arch prediction, but here accuracy metric I consider here root mean square error and mean absolute error. These all values mention some error in this model, but we can conclude that this model is fit for the forecast the air quality data, but in this error matrix we can conclude that we want to approve the any other branch model, EGRACH and TGRACH, some like other models to improve in the accuracy. These are the conclusion of my research. We can conclude that here branch 1.1 model is the best model for the Battaramulla area, and PM 2.5 shows high volatility persistent and PM 10 exhibit low persistent here. And in the previous plot, we can conclude that it is close to observed concentration for the prediction and the actual model. Then, and the RMSE and the MAE values, the errors are considered. If we can conclude that it is, if we can apply the any branch model for improving the accuracy. Then this is the future direction for my study. I hope to apply the advanced statistical model for the capture the asymmetric and symmetric more complex pattern in the pollutant behaviors like EGRACH, TGRACH and IGRACH model. Then we can improve in the forecasting accuracy. My final aim is I hope to build the hybrid model combining statistical model and the deep learning model and the machine learning model, combining both models to build the hybrid model to forecast in the air quality data, and then we can get the long-term predictions. Now these are the references that I used in my research. And this is the end of my presentation. Thank you for listening.
That's nice. You are a research scholar?
Sorry?
Research scholar or guide?
It was
What's the name? Madhu.
Madhu.
You are a research scholar or guide?
I'm the research?
Research scholar.
Yeah.
But you say that some places, most of the places is my plan, my paper, I wrote, I said. This is the combined work. Okay?
Okay, sir.
You want to give the respect to the guide. That's why our paper, use
Sorry
the
about
word
that.
our, avoid that type of my. Now you are the researcher under the guidance of some people. Okay? Avoid that word is I, mine.
Okay.
There are three numbers are combined. Suppose you write a single author paper, you said that my plan, my paper, I study, okay, no problem. This is the general format of the research supervisor and the student. Okay? Which one is? We go to slide number 7.
Slide number 7. 7.
That is one graph is there. 7, sir. Yes. What is the x-axis and y-axis? What are the values you take it?
The x-axis taken the values for the
Data.
date and the conservation for the PM 2.5 and PM 10
From the
conservation.
figure, what your conclusion is set? What is your idea is looking?
So in this figure, I get the idea. It is the data varies, the data change the over time. In this data set change the over time. Then conclusion is it is our original data set is the non-stationary data set. So we apply the so we convert the data as a first differentiation. Then again in the next slide we consider the ADF test. In here we confirm the result as a result.
T value is greater than whatever is less than. Okay. In the previous graph, there is a maximum or minimum. This is the maximum
And the minimum.
The particular term is minimum of that weight. That's why we use, this is our opinion for about the track, okay?
Okay, sir. Thank you.
Any question, please, audience?
So when I look at this time series, so I cannot see really the variance is changing over time, right? So why did you decide to go with the branch model over the other traditional model like Sharima, Arima models?
If it is stationary,
Yeah, usually in branch model, so what we do is like we try to model the variance, right? So volatility, it's not used. So when it's come to Arima and Sharima models, right? So we model the mean, right? So when I look at this two time series, so I can see that the variance is like kind of constant over the time.
it's constant. It's
Yes,
constant.
I mean like the gap, right?
Oh.
It changes over time
Yeah,
because it's
it's-
a time series, but the variance part like it remains constant over time. So what I'm asking is why didn't you use the Arima or Sharima in the first place?
Arima or Sharima models to for this one. So I use the Arima model in this data set also. I apply the branch model, Arima model, wavelet transform model for this data set also. And finally I combine all the best models to capture the data, best model to forecast the air quality data. So this is the one of the method for I apply in this data set.
Okay.
I also use the Arima and Sarima model also as a data in my next study.
Okay, okay. So because I didn't see that comparison, that's why I asked, because so looks like to me the variance is same over
Yes.
the period of time that you consider. All right, it's just a slight question.
Okay, thank
So that's all from my end. Thank you.
Thank you, sir.
Okay, thank you, Madhuvanti. You have done a very nice presentation. Timely, very important because climate is changing, but you felt that the last 2 weeks, then we are suffering from still. So thank you very much for you. Then next presenter.
Thank you, sir.
Computer integrated designing of prosthetic hands for the active of daily living. Thank you for your presentation.
Good morning, everyone. I am Gaya Gunawardana from Bionics Laboratory, Department of Mechanical Engineering, University of Moratuwa. My paper title is Computer Integrated Design of a Prosthetic Hand for Activities of Daily Living. There are 3 members in our group, Professor Ruwan Gopura and Dr. Kuduranand. So this is the outline of my presentation. A person can lose his hand due to various reasons like neuroma, work casualties and some industrial accidents. We can replace those missing hands using prosthetic hands. You can see how hand amputees can come back to their normal life with prosthetic hands. Moving forward to literature review. In our human hand, there are 27 bones and 19 joints. There are some finger motions as well, especially abduction, adduction and flexion and extension. Using above finger motion, human hand is capable for many grasping patterns. However, abduction and adduction are essential for power and precision grasping. When further narrow down to the individual finger abduction and adduction, we can identify grasping pattern like tripod, quadrupod, 3 finger and 4 finger pair. During my literature survey, I have evaluated 35 prosthetic hands, including 5 commercial prosthetic hands as well. Among those prosthetic hands, I found only 4 prosthetic hands with finger abduction and adduction motion. There is only one hand with individual finger abduction and adduction. This one is TN prosthetic hand. In this TN prosthetic hand, they use 9 linear actuators for controlling. And you know, in our human hand, when we get one finger, there are 3 degrees of freedom in one finger, but in this TN prosthetic hand, only 1 degree of freedom. So our aim was to design an anthropomorphic unactuated prosthetic hand with individual finger abduction and adduction. The novelty of the project comes with an individual finger abduction and adduction mechanism and unactuated finger with 3 degrees of freedom flexion and extension mechanism. These are the mechanism selection for the prosthetic hand design. There are 2 types of mechanisms. One is flexion and extension, other one is abduction and adduction. In my project, we mainly focus on developing a new abduction and adduction mechanism. There are 4 systems: spring system, gear system, clutch system and cam system are proposed for this novel mechanism. These are the finger mechanism used for the design. All of these designs are done by using SolidWorks professional simulation package and CAD modeling packages. So this is the proposed abduction and adduction mechanism. You can see in the left hand side how it works. There are 4 systems in this mechanism: spring system, cam system, gear system and clutch system. When come to gear system, there are 4 gears, and in spring system there are 2 springs, compression springs and torsion springs. I will explain how this works. There are 3 cam parts, and when particular cam part activates on the clutch system, clutches can engage, and with that engagement, fingers can move adduction position. So this is the proposed abduction and adduction mechanism and the cam system design. 6 finger adduction positions are identified. Using those 6 adduction positions, I generated 3 cam parts. Using those cam parts, develop a cam shaft for the mechanism. This is the CAD representation of the abduction and adduction mechanism. When come to the first one, initial position, no cam parts are engaged with the clutch plates, which means no finger adduction or abduction. If you can see the 6th one, all cam parts are engaged in the clutch system and all fingers can move to their adduction position. So this is the motor allocation and kinematic representation of the design. There are 8 motors in this system. 5 motors are allocated to finger flexion and extension. 6 motor is for abduction and adduction of the thumb finger, and 2 motors are allocated for gear system and cam shaft system. When come to the kinematic representation, you can see in green color, those are underactuated joints. Yellow color ones are actuated joints, which means there is a motor for each joint, and abduction adduction mechanism is representing in blue color. Here onwards, I will discuss about design analysis of the project. There are 2 types of design analysis. One is finite element analysis and other one is motion simulation. When come to finite element analysis, there are 2 load paths I have identified with this proposed system. This is the first load path. When particular cam part activates on the clutch system, clutches can engage. With this clutch engagement, I did a simulation series for this first load path. The measure is blended curvature mesh provided by SolidWorks, and selected material is 304 stainless steel. This right hand top corner is the boundary condition used for the simulation. Same as first simulation, this is the second one. When cam parts and clutches are engaged situation, the total system can rotate with the fingers. For this one as well, I did a simulation series using SolidWorks simulation package. I fine tune the mesh size until I get the converged result. The selected material is aerospace grade 15.5 pH stainless steel, and same as first one, blended curvature mesh is used for this simulation. So this is the motion simulation used to identify the finger trajectory of little ring, middle and index fingers and thumb as well. This one also done using SolidWorks motion simulation package. After generating prosthetic hand and evaluate the FEA and motion simulation, these are I generated grasping patterns using that CAD model to evaluate the capability of individual abduction, adduction, motion and grasping patterns. These are some generated images. First one is 3-finger spare, 4-finger spare, squeeze, tripod and quadrupod used to evaluate the model. When come to conclusion part, little ring, middle and index fingers have self-adaptive features. This proposed prosthetic hand is 18 degrees of freedom prosthetic hand and use 8 motors to plan to be control the prosthetic hand. Prosthetic hand can perform grasping patterns which require abduction and adduction like squeeze and abduction grip. So the prosthetic hand is evaluated using finite element analysis and motion simulation. So as a future work, this prosthetic hand can be manufactured for further research. So thank you everyone. If you have any question.
Yes, nice presentation. You are using one equation, K into U equal to F.
Yeah.
What is the K stands for? Global.
So that one is basic equation used for finite element analysis. And for the SolidWorks simulation, they directly didn't define any equation, but they give some solvers to solve the finite element analysis. And I didn't go for H adaptive or P adaptive simulations based due to some computational limitation and other things. So I use a basic simulation to evaluate the model.
This is the fundamental global equilibrium equations.
Yeah.
Okay. He used that two type of brackets. U is in the curved bracket, and K is square bracket.
Yeah.
Any difference between this type of brackets? Is it possible that?
Yeah.
You understand that?
Yeah.
You write the word.
Yeah.
Only says write down in square bracket. Okay, no problem. But you use different type of bracket in one equations. That's a mention. That's next.
Any questions from the audience? Yeah, I have one question. There is no question. Then this the artificial hands. Then how about the weight of the hand, and then it is equilibrium to the our left to right to left?
Yeah, this prosthetic hand designed for right hand width and pivot, and this is the prototype unit. Using that CAD model, we can assume the final weight of the hand. Final weight is around 1 kg.
Thank you, Gunawardhan. Then you have done nice representation. Then it is very important. Now I got that what is the complicated of the our natural hands. It takes more motors and more parts. So again, thank you very much for your presentation. Next presenter, design of hardware-based security framework for the genetic IoT devices, authentications, and using PUF.
Here in Open University of Sri Lanka, I will be presenting my work which is titled as Design of a Hardware-Based Security Framework for generic IoT device authentication using physical unclonable functions. The authors are me and Dr. Utpala Premaratna. When we consider the IoT devices, they connect billions of devices worldwide. And when we consider the IoT connection, they always share sensitive information continuously. Therefore, the security of IoT devices is very important, especially the authentication of the devices. Because if any attacker try to get the access to any of the devices, there may occur data breaches or system manipulation. And at present, there are different authentication methods for IoT, including software-based keys, cryptographic algorithms, and hardware-backed solutions. But when we consider those authentication methods, they are not only vulnerable to cloning, but they can have some side channel attacks, and also they are difficult to implement on low-cost devices. Therefore, there is a critical need for a lightweight, low-cost, and hardware-friendly authentication mechanism. So my aim was to design an unclonable custom digital design for physical unclonable functions for secure and low-cost authentication in IoT devices. When we consider the physical unclonable function, that is a circuit. In those circuits, those are IC integrated circuits. They are unique for each devices due to silicon manufacture changes. It's like this: when we design the same integrated circuits, two same integrated circuits also, they have tiny random physical variations because of the difference in semiconductor manufacturing. So if the same circuit is cloned even, the response for a particular challenge varies. So PUF, which is called as the physical unclonable functions, work as a fingerprint for a unique device. There are different types of PUFs, such as delay-based, memory-based, and emerging physical PUFs. For my design, I used an arbiter PUF because they are purely digital and also lightweight designs. So here in this diagram, you can see an arbiter PUF. In each stages, there are two multiplexers, and for each stage, one challenge input is given. So the same trigger input is given to the both multiplexers, and according to the challenge, the connection means the path is decided according to the challenge. If the challenge is 0, the path will stay at the top. Otherwise, the connection goes cross, as cross connection. Because of the fabrication variations, both the paths will have slightly different delays, and at the end there is an arbiter flip-flop, and if the top path is faster, the output will be 1, otherwise the output will be 0. So as that, each challenge produces a different response, and from those we can get multiple challenge response pairs. So here you can see a 4-bit arbiter PUF that I have proposed for the authentication, and these are the obtained challenge response pairs. When we consider the authentication phase, what happens is, if an IoT device tries to connect to the server, first it has to authenticate, which means when in the authentication phase, when it try to connect to the server send a random challenge to the device. For example, if it sends 0110 as our one is a 4-bit challenge, the device feed that challenge into the puff, and then due to the silicon variations, the response will be 1. If the response is 1 only, the authentication happens. Otherwise, the authentication fails because the device is fake. Here you can see the block diagram in the authentication phase as well. Also, the specialty of our design is we can scale it up to any number of bits we want. Here you can see the block diagram of a 8-bit puff design and a 16-bit puff design. The analysis of the proposed design is, it is a low-cost and lightweight hardware, and also it is easy to integrate in IoT devices as there are no stored keys. It is clone resistant, and also we can improve the security by doing different enhancements, such as we can add an XO, or else we can do feed forward puff. So for the conclusion and the future work, in order to increase the security of this, we can add a feed forward puff and increase the security. And also I am planning to do the hardware implementation and do some environmental testing and improve the resistance against machine learning based attacks. These are the references I used for my design. Thank you.
Yes, nice. In your table form, that is called 4-bit, 8-bit challenge and 16-bit challenge. Okay.
Yes, sir.
Move on to 32-bit challenges available for this.
We can do that
Okay.
as well.
Okay. What are the difference 4-bit challenge to 8-bit challenge? What is the advantage? What is the movement of this?
If we do now in the 4-bit challenge, the challenge response pairs we have is 2 to the power 4, and if we do 8-bit, it is 2 to the power 8. So there are 2 to the power 8 variations, which means the security is getting higher. Increases, yeah.
Thank you, Annie. Any questions from the audience? Yeah, one question.
Yes. Trigger. Trigger signal, yeah. 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 If the upper path is faster, we get the output as 1. Otherwise, we get the output as 0. Yeah, currently, mostly they are using the software encryption keys, and those are saved in the memory. So if any attacker can hack the OS, they can extract the key. And also for the software encryption methods, they need a high memory to install the keys, but here it is a hardware based one. The encryption is based on the hardware, small silicon manufacture changes. So if we can integrate both together, the security will be higher. Yeah. It's like for each IoT devices, one puff circuit should be there. For each IoT devices, there should be a specific puff design. Yeah, it's a hardware-based encryption method. Yeah, because. Thank you.
I have one question. Then currently existing that software methods, and then you are doing the hardware methods.
Yes.
Then I have one question. Which one is the more effective, and what are the current available product regarding to the hardware authentications?
There are some hard arbiter puff designs, but our one specialty is it is a pure digital design. Therefore, we can scale it up to any number of bits we want, and it is easy and lightweight.
What are the domestic uses, what you plan to use, what are the areas planned to use this software hardware parts? In the banking sector or either other electronic devices areas? What are the highly recommended for this?
These can be used in the security.
Yeah.
Means these are used in the military.
Okay.
Because it's a hardware. Because for each device, different hardware puff circuits are there. I mean, one circuit cannot be used for another device. So it is used in high secure needed areas.
Yeah, thank you, Annie. Then again, thank you because you have done very nice presentations and timely important because the security, China is the leading country, but we can't protect security from them. But however, then we have to do more research and more research because security is the important. Then next percentage, the last percenter, dynamic node additions for the SDN enable cloud-based wireless sensor networks. Yeah, this is your time, please.
So, good afternoon all of you. I am W.H. Niluvani. My research title is Dynamic Node Addition for SDN-enabled Cloud-Based Wireless Sensor Networks. So, first of all, I'll give a brief introduction. So, the emerging technologies such as smart environments, industrial automation, and cloud-based IoT systems demand highly flexible, adaptive, and reliable networks. So, as the number of sensor nodes grows, the traditional wireless sensor networks face challenges like limited scalability and rigid and static configurations and high overhead when adding new sensor nodes, and the performance issues during reconfiguration. When wireless sensor networks combine with the cloud platforms, it can address the problems like data and processing challenges. However, even cloud-based wireless sensor networks struggle with dynamic sensor node addition, especially in time-critical applications like industry automations or emergency response. So, integrating software-defined networking, which is a new paradigm in compute networking, offers a promising solution by enabling centralized control, dynamic programmability, and a better visibility of network conditions. So, the software-defined networking is actually the separation of control plane and the data plane. So, the logic is handled in the control plane and the data forwarding will be done in the data plane. So, these are the related works to my research, and most of the researchers have explored about wireless sensor networks, which were mainly focused on topology control, reliability, clustering, and routing. And with the rise of IoT, some researchers have focused about the importance of cloud integration, which addresses the processing and data storage in WSNS applications like smart healthcare, smart cities and environmental monitoring. And recently, some studies have focused on SDN-enabled wireless sensor networks, which addresses the scalability. However, as my research gap, there is no research reveals that which specifically addresses the dynamic sensor node additions in the cloud-based wireless sensor networks in terms of scalability challenges. So this is the proposed algorithm, the dynamic node addition. So this proposed algorithm can enable cloud-based wireless sensor networks by minimizing the latency and minimizing the difficulties. So first, the control is initialized, which is built using RYU, and it begins to listen to the event from the switches. So the RYU is a framework, an SDN framework. So here OpenFlow is a SDN protocol. For this algorithm, I have used 1.3 protocol. So after initialization, the switches forwards all the packets. When a new sensor node sends a join request, the switch forward all the packets to the controller. And then when the controller learns the MAC address and the port that connected to, and then controller updates its internal mapping table. And then controller, if the packet destination is already known, the controller will send the packet to the correct port. Otherwise, the controller will flood the net until the location is learned. And after that, the controller will install the new flow rules in the switches. And then the controller will update topology graph and refreshes the routing path to ensure the scalability. So this is the creation of topology and testing of connectivity in MINET emulator. So I have designed 4 different network topologies using a MINET SDN emulator. So there are 4 different network topologies like T1, T2, T3 and T4. So T1 is small scale topology which consists of 5 to 10 nodes, 1 cluster and 1 gateway. And T2 is a medium scale topology which consists of 15 to 20 nodes with 2 clusters, 2 gateways and 2 switches. And then the large scale topology which consists of 30 to 50 nodes with 3 to 5 switches and multiple gateways. And the final one is a T4, a dynamic approach. It begins with the medium topology and the 5 to 10 nodes were added during the runtime in order to do the dynamic node addition mechanism. So these are the network performance metrics that I have evaluated. So these things are captured using Wireshark. And the first one is a data transmission. So the data transmission is how much data is delivered successfully in the different network conditions. So here the dynamic approach performs better than T1 and T2. At the lower traffic like 100 Mbps also it reaches 250 data transmission, and the higher traffic like 700 Mbps also it reaches 1400 data transmission in the simulations. In the average response time is how fast network can react to the data request. So in the simulations, dynamic approach gave the at the 100 Mbps load, it was like 3 milliseconds latency, and at the 700 Mbps load, the latency was 38 milliseconds. And the CPU utilization indicate how much load distribute in each controller. So here the dynamic approach indicates 85% of utilization than T4 T3 topology. So this is basically simulation in the development environment. So my future work is just want to move from this simulation to the real world deployments. So there are several factors I want to consider, like environmental interferences and hardware constraints and large scale sensor deployment dynamics. Thank you.
Yes, nice presentation. Go to your performance analysis, the figure. Yes. What is the first data transmission? What are the data we take as x-axis and y-axis?
Yeah.
Here is that network load is y-axis.
Yeah, network load, that is y-axis data transmission.
Y-axis is data transmission.
Yes.
How to take the data? Randomly or?
Yeah, I did simulation using Python scripts, and yeah, those data were collected randomly.
You accepted and never corrected in the data. The data should be taken randomly. We choose it.
Yes.
Compare the first and second figure. What is the improvement? What is the difference? This is a straight away. Here, 1 point, then turn over to higher. Any difference? Any idea about this? Any indicate about that?
It's a cycle.
You see the slide first and second.
Yes, sir.
The first slide, the line is straight away go. The second slide, 1 point, then take over the increase the data. The second is y-axis. What is the y-axis?
Second y-axis is a response time.
Average response time, that is rate.
Yeah.
The rate is increased suddenly.
Yes, at the higher high traffic load, the latency is increased.
Any conclusion about that? These two graphs?
Yes, sir. In the second graph, at the 100 Mbps second, it shows a 3 millisecond latency, and the 700 Mbps is like 38 milliseconds latency.
Yes. The particular time they will increase.
Yes.
You are the student or you are faculty? I think.
Yes, sir.
Your other, your one is one other.
Yes, one was, yes, sir.
You are research scholar or faculty? Teaching professor or research scholar? What is your role?
Are you a faculty or faculty research scholar?
Yeah, Professor asks, are you a scholar or attached to the faculty member?
I'm from University of Jaffna. So it's
Any questions from audience?
five to 10 nodes at a time. So I use the Python scripts. Using the time, it automatically join new nodes using Python scripts. No, yeah, I just a constant, like I just declared a variable, took 5 to 10 like, and then in that script, it automatically changes. Yes, sir. Yes, that's why I said this is basically simulation. When it comes to the real world deployments, there might be several factors to consider.
So I was thinking like, so algorithm will decide like how many number of nodes should be at. So it sounds more dynamic to us, so that's why I'm asking. All right, good.
I have a question, sorry, you said there are 4 different topologies.
Yes.
How is this topology contributes? What type of topology?
Yeah, well, T1, T2, T3 is static topologies.
What kind of topologies?
So first, small scale topology is 5 to 10 nodes and with one cluster, and medium topology is 15 to 20 nodes with two clusters.
I understand. How do you define topology here? You said it is topology 1, 2, 3 and 4.
Yeah, T1, T2, T3.
Is the conditions for the topology satisfied here for your first, second, third and fourth? Nodes.
Yes, nodes, sensor nodes.
Nodes. So you segregate like 1, 2, 3 and 4.
Sorry?
You segregate as 1, 2, 3 and 4. The nodes.
Yeah. Yes.
Yeah, I have one question, but you are doing the wireless net sensor. What is the maximum radius you can cover from the one nodes?
Maximum. It varies according to the sensors.
Yeah, according to your research data, what is the maximum coverage of the current?
It's basically the simulation. So.
It's depend.
Yes.
It's depend. Okay, thank you very much, Nilluani. Then thank you. Then I am going to brief this session. Then there are four research papers. First one, then Madhuwanti, it is a very nice research presentation forecasting the urban air pollution in Sri Lanka using JRC modules and effective in air quality management. But a very nice presentation, and then we got lot. And the second one, then computer integrated designing for the prosthetic hands for active and daily livings. Mr. Gunawardena did nice presentation, but everybody got how complicated to our hands, and then how very difficult to simulate to this hand. That very nice presentation and very nice research to Gunawardena in Go Ahead Future. And the third one, designing of hardware-based security framework for the generic IoT device authentications used in PUP. Miss Annie did it, but very important one. Currently, he is showing that very important hardware devices for the authentications. Currently, softwares are using. Thank you very much for your nice presentations, and then go in future. And the last one, then Ms. Neil Nuvane did that the dynamic node additions for the SDN enable cloud-based wireless sensor networks. Then thank you for your presentations also. And then you are doing a single author presentation. Again, thanks for your one. And then we are going to conclude these lessons. And again, thank you invite for us to these sessions. And then thank you for you. Okay.
Thank you, sir, and for the presentations. Now it's time for the certificates distribution for the presenters. For that, I would like to invite Professor M. Srinivasan to join with us. Miss D.M. Sachini Kaushalya Madhuwanti. Mr. Gayan Gunawardena. Thank you, sir. Next, I would like to invite Dr. Sudat Rohita to join with us. Miss N.R. Ann Princess. Miss W.A. Gimhani Nilluwani. Thank you, sir. Now I would like to invite Dr. Ramesh Tanuja to present the token of appreciation for our session chairs. And I would like to invite Professor M. Srinivasan to the stage as well. Thank you, sir. And I would like to invite Dr. Sudhat Rohit. Thank you, Dr. Ramesh. And before the session concludes, I would like to invite Professor M. Srinivasan to an invited talk on Markovian queuing model with multiple working vacation. Professor M. Srinivasan is currently working as Associate Professor, Director in charge of CDOE, Annamalai University, and he has 22 years of teaching and 20 years of research experiences. His research area is stochastic process and its application, and also graph theory and computer networks. So over to you, sir.
Good afternoon to all. My sincere thanks to the organizer for giving me the opportunity to present the paper. My topic is Markovian queuing model with multiple working vacation. Normally we know that mathematics can be divided into two parts. One is deterministic, the another one is non-deterministic. Deterministic means the solutions are determined to hold true with the absolute value. Non-deterministic means probability. That is, deterministic means the sure event. Every Sunday is a holiday. Normally we say that. Non-deterministic, not sure event. That is, every Saturday may be a holiday. We say that what is your long hole, how to scan. Next one is birth and death process. This is the most commonly used queuing model. What is birth? Equivalent to arrival of the customer. Death means departure from the service. We use the discrete random variable. What is this? This is a finite number or countable infinite number of values through a die. Continuous random variable. It takes a interval, the period time. There are 4 classification. Discrete time, discrete state phase. This is the number of accident at some time, 9 p.m. or 10 p.m., 11 p.m. That's called discrete time, discrete state phase. Next one is discrete time, continuous state phase. Number of accident on highway on an interval time between particular time, 9 to 10. This is called discrete time, continuous state phase. Next one is continuous time, discrete state phase. This is the age of people in a city. A popular, the term is particular year, 2001, 2002, whatever it is. That's called continuous time, discrete state phase. Next one is continuous time, continuous state phase. That is interval. What is the example? Age of people from particular time, March 2013 to March 2014. This is the particular period we noted continuous time, continuous interval. Most generally we use that queuing theory. The analysis of description and real world phenomenon through probability theory leads to stochastic modeling. Queuing theory is one of the most important field in the stochastic modeling. This is the history of queuing theory. The A.K. Erlang is the father of the queuing theory. Published his fundamental paper relating the study of conjunction in telephone traffic. Danish engineer who in 1909 experimented the fluctuation of telephone traffic in Copenhagen. In 1917, he published a report, The Delay in Automatic Telephone Exchange. At the end of the World War II, his work was extended to more general problem, including waiting line. Kendall notation is there. A queuing model is described as a series symbol A, B, X, Y, Z. The first A denote the inter-arrival time distribution. Second, B, the service time distribution. Third, X is a number of parallel channel. Then Y, system capacity. Then Z, queue discipline. This is one example for the average arrival rate lambda in second, minutes, hours, days. We know that probability mass function f of x equal to e power minus lambda, lambda power x by lambda factorial. We take one example. If the average arrival rate per hour is 2 people, that is lambda equal to 2, what is the probability of 3 people arrival at per hour? How to find? This is the keyword. The example is for using the formula p of x equal to e power minus lambda into lambda power x divided by x factorial. We substitute that lambda equal to 2. We find out the result. 18% of the result, the people arrival at 3 people in 1 hour. Next we move on to exponential distribution. This is for mu, average service time. The t is length of the time. The probability of p of t is service time will greater than the limit time t. This is a queue. A queue is a waiting line which usually formed in front of the service facility is called a waiting line or queue. Wait to eat at restaurant. This is also a queue, for example. Wait to line at a grocery shop to check out is also a queue. Wait in beauty parlor or barber shop is also a queue, waiting line. These are the components of the queuing system. Major part is calling population, form a queue, then get the service mechanism and leave out the system. This combined part is called queuing system. There are components. Calling populations are such as arrival process, queue discipline. Queue discipline is, we know that first come first out, first come first serve. Last come first out is also there. Random order. These are the queue discipline. This is the queuing system. A queuing system can be described as customers arriving for service, waiting for service if it is not immediate, and if having waited for service, leaving the system after being served. This part is called queuing system or queuing model. This is the basic elements. Arrival pattern of the customer. It specifies inter-arrival between 2 successive consecutive arrivals. We denoted the Poisson process. Inter-arrival times are independent and exponential distributed. We know that this is the inter-arrival time. Batch arrival. This is called bulk arrival. Next one is components, that is specific number of queues. Is single line or multiple line? There are number of service station. Their effect are customer behavior. There are minimum 3 part, that is bulking, reneging and jocking. What is bulking? The arriving customer saw the queue is too long. If the customer decide not to enter the queue upon the arrival is called bulking. The customer waiting for service now. We check out, the queue is too long, then they return to this. This is called bulking. Suppose the customer see the queue and enter into the queue, just wait for some time and leave the system for the impatience. This is called reneged. We know that, for example, Taj restaurant, we are waiting for the service, we get the food. Some places waiting in the place, the customer at Taj, this is some waiting 30 minutes, 20 minutes, fixed something. This is the format of queuing system. And another one is jocking. What is the jocking? If there are two parallel queue, the customer switch one queue to another. Customer decide that queue is moving fast, then move on to this. Then we see that this this server is closed. After that we go move on to this. The customer behavior is jocking. Next one is feedback customer. After service completion, the customer may, under some decision rules, not satisfied their service. Then we move on to the another service. That type of a customer is called feedback customer. This is two configuration queues. The first one is single queue. There are 4 servers are fixed, but the customer enter into the system one by one to head of the queue is moving to the free server. That is single queue. Next one is 4 server, 4 lines. This is multiple queue. Queue discipline, already said that, first come first serve, last come first serve, and service in random order. And also one of the term is called periodic queue. Some VIP is coming there, the queue is enter into that, the VIP, all other queues are closed, the VIP is enter. This is also a periodic queue. And one of the term is called hospital management. The accident cases come into the first priority for the service to the patients. This is also a priority. Single server queuing system. This is multiple server queuing system. Single server means only one server. Multiple is there are one more than one. Waiting time. The waiting time in queue refers the time spent by the customer in waiting before service. Suppose the waiting time in system is the waiting time before service, and adding that plus service time is also the system. We combined with the waiting service. Next one is busy period. A busy period starts arrival at an empty service and end with the empty service. That term is called, in between that term called busy period. Next one is server breakdown. A queuing system may suddenly break down, and hence the server will not be able to continue the providing service unless the system is repaired. This is called breakdown. Next one is heterogeneous server. The service time distribution may be different from different server. Next one is catastrophe queuing system. When occurrence of a catastrophe, all the customer in the system destroyed immediately. That type of system is called catastrophe. Next one is restoration time. The system takes its own time to ready to accept new customer. This type is called restoration time. Next one is system capacity. Number of service channels. This is a queuing model, MM1. The first M refers that Poisson arrival. Second M, negative exponential distribution. Third one, single channel, single server, denote that. This is MM1Q. Next one is MMSQ, the same. S is a multiple channel. mm1k, the same last k is capacity. Next one is mg1q, the same m, g is general, that is central normal curve, that is service time is general. Vacation time, after servicing certain number of customers ruled by specific service discipline, the server may becomes unavailable for a period of time called vacation time. There is no customer in the system, server take the some other work, that is called vacation time. In the vacation time, the setup time. After vacation, the server for further service. Then if the server return to the further service, the queue is still empty, there is no customer, the server take another vacation, otherwise server needs setup time, may attend the waiting customer in order. That type is called vacation time, setup time. No customer in the system, the server wait for some customer. Types of vacation, that is single vacation. There is only one vacation period if the system is empty. After the vacation, the server simply waits for a customer rather than starting another vacation. This is called single vacation. Next one is multiple vacation. Multiple vacation is also a no working time, that is no customer. In this model, the server stops all service completely during a vacation if only return to the serving customer when it finishes the vacation and finds non-empty system. This is called multiple vacation. Next one is differentiated vacation. That is type 1, longer vacation. Next one is the working vacation. During the vacation period, if there are customers waiting for service, if the server may serve the customer with lower rate of service rather than the completely stopping the service, that type of service is called the working vacation. And another top is multiple working vacation. If queuing theory, a multiple working vacation means the server provides server service at a reduced rate when the queue is empty and continues to take this working vacation if the system remains empty upon returning. This is a normal vacation, but service completing staff. The feature of multiple vacation, reduced service rate, vacation interruption, multiple vacation, normal service. These are the key feature of the multiple working vacation. What is reduced rate? The server provides service during a working vacation, but a slower rate than rather than normal busy period. This is called reduce the service rate. Next one is vacation interruption. If a certain number of customers are waiting for a service, working vacation, the server can stop the vacation early and return to its normal. This is called vacation interruption. Multiple vacation. Next one is normal service. This is the example for normal service. A librarian who works at full speed in regular mode and at a slower pace during a working vacation while students form a queue in the middle. Suppose the student form in the queue, then server, the librarian move to the faster service. Vacation type. The vacation is no service. Working vacation, reduce the service rate. Multiple working vacation, multiple mode with slower service rate. This is the different. State transition diagram. This is applications. The call centers, computer network route, healthcare system. Here they are using that applications, manufacturing and production line, retail and service counter, transportation and toll system. These are the applications of the multiple working vacation. The cloud computing and virtual machines. Here is the call center. An agent at a call center has a full of call. That is, instead of taking a full break, they enter a working vacation state to perform other duties, such as updating a customer's account and responding to email. This is called call center work. Next one is computer network routes. Healthcare system in the hospital and clinic. Manufacturing and production line. Slowing down due to the wear and tear. Reduced to speed mode. Retail and service counter, different administrative takes gives rise to multiple working vacation. Transportation and toll system. Each reduced rate mode can be modeled as a different working vacation. Now we move on to that car to straight away to cross the place. Cloud computing, virtual machines, that is reallocating the resources, security scans, rebalancing workload, advantages and disadvantages. These are the advantages. Increased service utilization, flexibility for interruption, improved efficiency. These are the advantages of multiple working vacation. This disadvantages is only for slower service rate is a disadvantage, and increased customer impatience is also a disadvantage. System complexity is also there. This is the slow rate, increased customer impatience, system instability, system complexity is there. Any question? Due to the time concern, we move on to that. This is the one type of queuing model, that is multiple working vacation. Okay, thank you.
Thank you very much, sir. We have a token of appreciation, sir. So I cordially invite you to remain in the stage, and I would like to invite Dr. Tilina Tantiriwatta to hand over the token of appreciation. Thank you, sir. Sir, can you please remain on the stage? I would like to invite Dr. R. Ramesh to the stage. Thank you. And with this, we remarks the end of the session 14th of ICIRT 2025. Thank you for